第6届国际太空站 Kibo 机器人程式设计挑战赛的现场。Kibo RPC 提供了学生在太空中学习机器人的技术和程式设计的教育机会。祝福所有队伍都能在今天的比赛中表现出色，收获满满。也感谢所有指导老师、评审嘉宾及工作团队的辛劳与付出。接下来，让我们邀请国家太空中心太空教育办公室郑崇生总监为我们介绍嘉宾及开场，让我们掌声欢迎。
首先欢迎各位同学、各位老师，还有我们现场的长官来到这边。那这个活动基本上已经办到第6届，不好意思，办到第6届。那其实一路走过来，人数越来越多。那我们也看到先前来参加我们这个活动的同学他的发展都非常非常的好，因为它是一个很高度整合的一个应用，它会比你们直接单纯去参加 FRC 或者是 VAX 这种机器人竞赛还要有趣一点点，因为它是实际应用在太空科学上面的一个实作。那你们写的程式当你们拿到冠军之后，会跟着我到日本去现场看着你的机器人在那边太空中那边跑，然后去跑完结果出来，然后来做一个较量那台湾在前年拿到冠军，全世界的冠军，蛮厉害的。那去年第4名，不过每一年报名的人数其实越来越多，像今年就是有史以来最多人报名的一年，不止在台湾，在全世界太空这个热潮你可以很明显的看到它非常非常的热。那我们在这个过程中，我们可以及早去接触到太空的一些应用，那往这个地方来发展。那如果大家觉得很有趣，那当然可以到我们太空中心来不然其实蛮多相关的领域都可以来发展的。好，那我的责任是介绍今天的贵宾不好意思，我看一下小抄那我们今天来的大概最重量级的人物，就是我们台南市非常非常支持我们这个活动。那我们市长亲自郑兴辉局长亲自来这边跟我们勉励。那我们欢迎郑局长。然后我们成大副校长李永春副校长也来到我们现场，给我们一些指导跟勉励好，那我们这是最辛苦的主办单位张怡玲教授。那他帮了我们很多很多的忙大家应该都跟他蛮多的接触的，那谢谢他。好，还有我们一个很重要的是我们课程发展科台南市教育局课程发展科的张世伟专员，谢谢。台南市今年说我们台南市其实这个活动办在这边所以台南市市长这边有给我们一些额外的 bonus 的奖金加成等一下我们最后面颁奖的时候大家就会知道。我们也谢谢市长，因为市长最近去看灾比较忙，他本来要亲自过来，就有了我们市长来我们这边帮我们指导一下好，那当然最重要的就是说比赛一定要有分出一个胜负嘛胜负除了你们实际跑的成绩之外我们今天也邀请到非常非常专业的评审委员过来那首先我们介绍我们国家太空中心的杨善国郑工程师。大家不知道这个活动其实就是善国去日本这边帮我们引进来的，然后杨工程师呢，他也是台湾第一批派去美国受训的太空专业人员。对，好，就是元老级的。对如果大家对这个地方太空任何有兴趣的任何议题有兴趣的话，会后或者会中有空余的时间都可以来请教我们的杨工程师他也是我很照顾我们的一个前辈然后再来就是另外成功大学土木工程系的苏瑜琪教授，那他们来帮我们担任一个评审，给我们一些指导。还有成大工科系的黄朝伟教授，这2位教授都非常非常年轻那也对这个机器人这个领域里面有蛮多的一些造诣的好，那我们就先预祝我们活动圆满成功。那接下来我们邀请我们的局长来帮我们做一个致辞跟指导。
非常谢谢我们国家太空中心，这个位置刚好，这个要找适当的位置站好。那我们郑总监，还有李副校长，还有张教授， 还有我们杨工程师哈，还有苏教授，还有黄教授，还有局里面的伙伴，以及今天最重要的主角哈，各位参赛的年轻朋友啊，各位工作伙伴，大家早安，大家好。看到年轻人的精神都起来了哈。那如同郑总监刚刚提到的，台南的确在这一次的风灾里面呢是受损蛮严重的，所以市长这几天也都在这个灾区啊做巡视，包括我们的学校，从整个停电85校哈，那么到今天早上呢，大概剩下9+1啊，不过总的来讲是大家全车全力，总的赶快让校园做复原的工作哈，当然是题外话。那所以市长没有办法亲自来，特别指派我，那么要代表他，那么感谢我们国家太空中心还有成大，那么来合作办理今年我们算第6届国家太空的这个太空站机器人的这个城市设计这个大赛。我想对台湾来讲，那个郑总监刚刚提到了，去年我们拿到冠军，前年那去年拿第4，但今年希望再拿回冠军因为台南说实在的，当然今天与会参赛的有来自各县市不是只有台南，不过总的来讲，台湾队就是一个对我们来讲是一种荣誉也是一种骄傲。我要讲骄傲，不是表露在脸上的骄傲，而是我们骨子里面呢有我们傲骨。我们教育人员常常讲不能有要傲气但是我们要有傲骨所谓不服输，然后持续自我精进能够在国际大赛里面呢拿回台湾的荣耀。我想台湾在过去曾经是被列为可能国际上人家讲台湾还要再问一下在哪里，你还要画一张地图给他看。那曾几何时，现在在台湾大概没有人不知道所谓台积电甚至半导体不是只有台积电而已可以说我们的人才也非常的多，不只是台积电，连即将在我们的沙仑设 AMD 这个研发中心的苏志峰都是我们这个台湾的女儿哪怕 NVIDIA 现在国际的数值资产那么最富有的这个突然忘记他名字，黄仁勋叫 Jason 那基本上都是我们台湾的可以说优秀的子弟，所以我讲各位潜在的会有下一个台湾的骄傲。那我想这个一定要从基础开始打起。那台南是因为是科技重镇省立高阶，包括S 廊带、大南方，未来都会是台湾呢甚至全球重要的所谓半导体甚至 AI 的研发一个重镇。所以我讲对台南部地区来讲，也是一个非常好的学习以及工作的场域所以跟各位年轻朋友，或许还有一段时间但是会在即将的未来都可以成为各位的梦想这个实现的一个场域所以在这里非常谢谢。那我想台南的确对这个 AI 机器人还有城市设计，我们从国小就开始有一定的课程，那么在打底。那在座的各位也有我们台南10队应该都是身经百战的。那当然同场较劲的不是只有台南，我想台湾的各个学校，大家利用这样的一个竞赛机会比赛总是有输赢，但是透过这样的竞赛结交好朋友只要你对这个部分有兴趣，我想都是各位可以发展的一个舞台。所以谢谢国家太空中心，未来如果有更多的比赛都可以，我们台南都非常乐意来配合。那当然成大是我们最重要的产官学的学术非常重要的基础。那我想大家一起来合作，一定可以为不只是台南，甚至台湾，那么营造或是储备更多优秀人才成为未来台湾的骄傲，也是全世界的骄傲再一次预祝我们这次的竞赛非常顺利圆满，各位能够大展身手，结交更多的朋友。谢谢大家，谢谢。
好啦，谢谢局长。其实刚刚讲到黄仁勋跟苏之峰都是台南人，对，他们是台南帮的后代，好像苏之峰要叫黄仁勋 uncle 的样子。而且他们都，因为我之前在南台啊，所以他好像是我们董事会，就是台南帮里面的，所以台南真的是科技发展的一个重镇啊。那未来我觉得像现在台积电的发展，然后沙仑这边也慢慢会起来，那大家如果有机会也可以往台南这边来看。当然不止台湾、台南啊，其实刚刚局长说，其实这是代表台湾的一个荣誉的。好，那我们接下来邀请我们副校长来帮我们讲几句话，跟大家做一个勉励，谢谢。
OK，太空中心的郑总监，还有台南市政府的郑局长今天很荣幸邀请2位贵宾来成大。那还有我的主办人，我是成大机械系的，刚好跟今天的主办人张怡玲是同事那我知道这件事情，觉得非常的高兴，我们成大可以来主办这个活动。那我也稍微理解了一下，那我知道今天各位同学会非常的因为我们还有好多队，30几队要来进出一个名额，只能派一名去日本参加这个国际的大赛，所以大家今天一定会非常的这个聚精会神，而且下午还有北部来的英雄好汉跟大家一起切磋。那作为成大的代表，我们是地主我们衷心欢迎各位。那有几件事情跟大家分享，一个是刚才郑局长也有提到，国家正在推这个S 廊道，南方 S 廊道另外一个名字叫做大南方新矽谷昨天刚好在沙仑才召开这个活动的会议，我们国家放了非常多的资源那这个里面最重要的就是 AI 机器人有各项很多项了有很多个要发展的项目。那么也很高兴我们这个国实院，就是国家实验研究院的一个最新的一个研究中心将会落脚于沙仑。这个里面有成大非常多的老师会参与建制，还有配合国内很多的研究团队跟厂商，所以说不定有一天各位所做的东西可以进到这个基地里面去做机器人的实作。因为今天大家做的是 programming那边这个基地成立以后呢，会有很多的实作机器人，让你可以把你的 program 实际去操作与验证那这是一个那第二件事情我要讲的就是各位知道吗？台积电最近有对这个几个比较国内的顶尖大学台城清交都有做大量的捐款，用在什么地方呢？一年都很多钱了用在什么地方呢？台积电特别指定要 STEM STEM 就是Science Technology、Mathematics 跟 Engineering 这个东西。那我刚好负责接手这个问题的时候，就会问台积电说：为什么台积电这样一个高科技的公司，会对高中、国中甚至国小当然也包含大专这个 STEM 教育这么想要投注心力呢？他的回答非常简单，就是台湾就是靠人就是靠我们的人才。那现在呢，台积电已经把所有的人才都吸纳的快要没有人了所以他一定要从最基础的来培植我们的更多的国中、国小甚至高中生投入这种科技科学、数学还有各项的这个活动所以各位可以知道国家是如何重视的这件事情，还有产业界那最后我只想用也是一个听到的一个讯息来跟大家。有一位教授曾经评估台湾的这个经济规模就是我们台湾每年的 GDP 工业产值他说我们按照这个台湾的每年的对世界的贡献我们应该是一个9000万人口的国家，各位了解但是我们事实上只有2300万，这代表什么呢？各位一个人要当3个人用也就是说你现在做的事情呢，不是为你一个人你要为3个人的工作呢而努力所以我们要把我们的所有的台湾的这个国民从小学、高中，这也是郑局长的这个身上的大任要把每一个人呢发展成3个人的能力呢，才能支撑我们国家往后面的继续的发展那无论如何呢我只是来参加这个会的时候，我想起我小时候看那个电影叫 Stand by Me这是一个很有名的美国的电影，它叙述一个高中生跟一群团队在他们的学校练习怎么射这个火箭这个电影可能有30几年了30几年。那么他们受到老师很大的这个支持，终于把这个火箭射上去了中间过程当然非常的复杂 最后呢，这个高中生呢，成为美国 NASA 的太空工程师的总工程师啊，所以从小的梦呢就会投射到未来，所以每个人在小的时候一定要有那样子远大的梦想啊，他一定会成功，只要你持续不断的努力。好，那最后我只是预祝今天的活动能够顺利成功。每位同学在紧张的竞争之余，不要忘记去认识您周遭的朋友啊，他们都是来自于全台湾各地最优秀的。认识朋友也是今天活动非常重要的一环。那预祝大家都能够顺利成功。好，谢谢。
欢迎今天出席活动的贵宾、评审们，让我们再次以热烈的掌声，感谢各位贵宾的莅临。在进入比赛之前，我们邀请所有与会贵宾以及各个参赛队伍的老师、同学们，尽可能往座位中间区域移动，一起来拍摄今天的开赛大合照。请注意不要进入最后一排摄影团队的区域，谢谢。大家尽量往中间移动。
还没打开。
没事。
哦，可以。然后大家都 OK 了吗？来，看我这边笑一张，来，3、2、1。可以帮我比个爱心吗？小爱心，来，3、2、1，西瓜甜不甜？甜耶！看一下。好 ，OK， 谢谢大家。
在报告开始之前，简单介绍一下程式任务。在本次任务中 ，Astrobi 将从接驳站出发，巡逻希望号内4个具指标性的地标区域，回报各区域的地标数量，并记录可能藏有宝藏的位置。巡逻途中，队伍可选择经过绿洲区，以获得额外的积分，其加分多寡取决于 Astrobi 于绿洲上的停留时间。当巡逻结束后 ，Astrobi 会前往太空人所在的位置，辨识其所提供的真正宝藏资讯，并前往对应区域拍摄宝藏照片。拍摄完成后 ，Astrobi 将启动信号灯，通知太空人宝藏所在的位置，任务即完成。 接下来，我们进行今天的报告规则说明。本次竞赛采取上下5场方式进行，由参赛队伍依序上台报告，每队报告时间总共为3到5分钟，期间将响铃2次作为提示，第1次于第4分钟响铃1次。提醒参赛者时间剩余1分钟，第2次将于第5分钟响铃2次。届时，参赛者需立即结束报告。请各队务必留意时间的掌控，确保能完整呈现重点内容。接下来是有关预赛评分的说明。本次预赛的评分分为2个部分，初赛用的 APK 程式占总分的 90%， 而今天的现场英文报告占总分的 10%。每队的表现将由3位评审进行现场打分，以技术、创意和报告的完整性来评分，并于下午进行成绩汇整与颁奖。而闭幕典礼之后，可至外面柜台处领取参赛证明。若有同学需提早离席，也可以提早至柜台领取。请各队依照工作人员引导，依序进行准备与演示，也请台下观众保持安静，让参赛者能够全力以赴。接下来进入比赛，有请第1组 Nebula 上台报告。第2组 Mini Pekka， 请到前面第2排准备区做准备。
Good morning, everyone. We are Nebula, and this is our technical report. The first one is team introduction. So we call this name for our team is Nebula. It means for a cloud of gas and dust in outer space, visible in the night sky. And it also means to represent the news. We can use this cloud of gas and dust to become a new star. So we have 2 seniors and 3 rookies. So which means we can participate in the Kibo for the 2nd year. And we also want our rookies can learn more about this competition. So they will join us and learning in path planning and also the object recognition. And the second one is technical report.
Path planning, we first calculate the midpoint of 4 axes. And then we ensure that Astrobee can capture our target item. Finally, we use fine-tuning to check that we can get the offset bonus.
So as you can see, in the previous version, we used the path planning simulation and also to get the midpoint and using the fine-tuning. So we can get a bonus for 5 to 8.2 points. And the second one is when the Astrobee gets to the photo, it will calibrate the photo and resize and crop. So when we move to the closest point of the rounding report, and it will get a photo. And we can use the Aruco to using Aruco TVEC and RVEC to resize the image like there. We can get 1280 multiply 960. And because our object detection needs to be the square, so we will resize it to 640. And so we can use it to filter the IDs and also using the to calibrate the correct image. So we can improve the accuracy by using this. So this is our sample annotating by using the RoboFlow. The first one is the origin, and the second one we can use the crop photos like the previous. So we can save those photos and we can use it to use it in the annotating. And also we use the Python to like using it to transform, overlapping, and rotate it. So we can annotate it to more than 20,000 photos and 60,000 annotations. So why we want to use object detection, not using the bounding box or classification? It's because we can get the multiple objects and the position info. It's a little bit hard, and but it will get more accuracy.
We organize the data sets into training, validation, and testing sets, and annotations follow YOLO formats or normalized between 0 and 1. We use YOLO V11N, a lightweight object detection model. It takes 640 by 640 pixels, and it will output in bounding box and class probabilities. And we train the model for 100 approaches with a batch size of 16, and the optimizer and learning rate stakeholder are set automatically by YOLO V11N, which cosine decay. We also apply advanced data augmentation like mosaic, color jittering, random flip, and erasing to improve generalization. We first studied pre-training YOLO V11N weights and modify a model for 11 classes. Each batch goes through augmentation, forward pass, and back propagation. Valid is run after every approach, and the best model is set based on metrics like MAP, precision, and recall.
And also want better model training algorithm and improve data accuracy. Thank you for listening.
感谢第一组的报告。接下来我们来看一下该组程式在模拟器上面的表现。区域影像辨识成功。第二个影像辨识也成功了。所有区域的影像辨识都成功了。最后也成功辨识了，谢谢我们第一组。接下来有请第二组 Mini Pekka 上台报告，第三组 Astro Sheep 请到前面第二排准备区做准备。
Hello everyone, our team name is Mini Pika. Team introduction. Introductor Zhang Songyu, graduate from National Cheng Kung University with a strong programming background. Team leader Wu Pingcheng has excellent interpersonal skills effectively managing conflicts and different opinions. Vice leader Cai Zhenyu is highly creative and often solves problems from unexpected angles. Path recognition Su Yizhen and Cai Zhenyu. Image recognition 郑以谦 and Wu Pingcheng. English report 黄志行. B. Programming strategy.
After studying the competition objectives and the ISS cabin model, we learned the pros and cons of earning additional OSS zone points. Considering the risk of condition failures, we decided to prioritize stability over aggressive scoring. C. Key technical challenges. Positioning errors and PID understanding. Initially, we tested API Move 2 by keeping the astrobee at the origin, but we found large differences between our input coordinates and the logs. Even with repeated commands, we began a keeping zone 1 test, and the error disappeared, leading us to suspect that the astrobee was stuck near the starting point. This little turn point led us to unexpectedly discover the PID automatic control system. Key technical challenges, positioning errors and PID understanding. Create precise AR tag alignment. Since AR tags are not always centered, aligning precisely was challenging. We came up with a creative method. Align the cameras to the area center, take a photo, calculate the distance between the photo center and the AR tag using the Pythagorean theorem, and then estimate the real-world size per pixel using the AR tag's known size and its pixel size in the image. This allowed us to fine-tune the astrobee's movement size and direction precisely. This allowed us to reduce the final error to only 3.6 degrees. We later realized that this method was essential for improving our positioning accuracy. Here is the footage from the simulator, which is the actual calibration process. Because the footage is kind of long, so we doubled up the speed. Image recognition breakthroughs. We first used template matching, which was too sensitive to lighting and angles. Initially, we tried feature matching using ORB with BF matcher. We slightly reduced misrecognition, but did not fully solve this issue. After further research, we switched to YOLO V8 for detection. YOLO V8 uses convolutional neural networks, which is CNN, to extract layers features from lines, angles, and simple shapes to complex patterns. Through custom training using potential in-cabin images, this dramatically increased recognition accuracy. This journey taught us in engineering bottlenecks often result from using the wrong method, not from writing too little code. The transition from template matching to ORB at BF matcher to YOLO V8 was a significant step forward in our computer vision skills, and we look forward to using these techniques in more complex environments. D. Conclusion. Through this Kibo RPC journey, we learned how choosing the right method, continuous testing, and a stable strategy and key in real engineering challenges. We advanced from basic testing to mastering homography, feature matching, and YOLO V8, while also gaining hands-on understanding of PID control. We look forward to using what we learned here to tackle more challenges, robotics, and computer vision problems in the future. Thanks for your attention.
谢谢第二组的报告。接下来我们来看一下该组程式在模拟器上面的表现。
风雨侦测成功。Data 也侦测成功，侦测失败。 他可以按着任务场。
谢谢我们第2组，有请第3组 Astro Ship 上台报告。第4组 Space Hero 请到前面第2排准备区做准备。
Hello, everyone. We are the Astro Sheep. We came from a diverse background, but we are united by the same passion for space exploration and technology innovation. Today, we'd like to share our passions with you guys and connect with our fellow enthusiasts. Now, let's dive into the programming parts. Now, when we're introduced to this mission, first we all think, now, what a human will do. Well, first, if you and I were floating in the ISS, first we'll definitely look around for clues, and then we'll move carefully, and then we'll check out our environment and then seek the patterns around us and then report back the mission, right? Now, this is the easy part, but when we want to convert it into some programming aspect, these are the part that we divided into. First of all, navigation. You have to move around the ISS. Perception. We have to read and analyze the environment around us to understand it. And then we have to recognition. So what is the treasure? What does it look like? How do we know what it looked like? And lastly, report. Now we have to report back what the treasure is, where the treasure are. Now to implement this, we use object-oriented programming to organize our code neatly. And we use the Kibo API class for high-level robot commands. And we use cross-language programming, including OpenCV, TensorFlow libraries for efficient real-time variation tasks. Now let's move on to the key technique and difficulty part. When we want to recognize an image, for example, like these above, we'll face many problems. So first, we'll have to use Aruku markers to find out where the image are. What does the picture look like? And to apply scaling perspective for our robot to identify it. And then we'll move on to the YOLO V8 model. YOLO stands for You Only Look Once. It's a real-time object detection algorithm that look at image to define what an object are, mechanics. And why we choose the V8S version is because it has fewer parameters, making lightweight and suitable for AstroBee's limited computing resources. And despite being small, it has high accuracy. However, when we are trying to do it, during the process, we encounter many difficulties such as this. We found out that lighting varied in ISS, changing image brightness, and we'll have noises that will come from the sensors. All of this, plus the different viewing angles such as these above, will increase the difficulties for our AstroBee to recognize these images, which will become to failures. Now, to solve these problems, we use extensive data argumentations to train the YOLO V8 models to be robust in any situations. First, we randomly choose different types of templates to simulate the variety of items AstroBee might see. And then we generate training images with random size, rotations, including overlaps, of course. And then we apply it with different noise and blur effects to simulate what real-world simulations, how AstroBee would look. This process created a diverse and realistic training. This will include in a diverse and analysis, making our AstroBee have a precise and conduct image like this. We use no less than 5,000 photos to train our models. Now, throughout the whole process, we learn the ropes and basics of machine learning, to try and error, but most importantly, we've learned how to learn, as cliche as it sounds. And it's a never-ending process, and throughout the journey, we apply upon the knowledge we learn and the teamwork by communicating with each other. Now, I would like to use the Space Oddity from Space Oddity, the song from like the Secret Life of Walter Mitty to tell to the ISS float to the ISS that's floating above us right now. As the song concluded, ground control to Major Tom. They are just like the Major Tom in the movies. They're the pioneers, venturing into the darkness, not to be lost, but to light our way for all of us on Earth. So yeah, thank you.
谢谢第三组的报告。接下来我们来看一下该组程式在模拟器上面的表现。好，谢谢我们的第三组。接下来有请第四组 Space Hero 上台报告。第五组 Three School 请到前面第2排准备区做准备。
Hello everyone, we are Team Space Hero, and this is our presentation for the 2025 Kibo RPC. Our team has 4 members, 2 from Guard 11 and 2 from Guard 10. We all have a strong passion for programming and robotics, and leader is John Ray, who directs the main idea and the projects.
We believe that AI will be more important in future technology. So we use an AI assisted to approach our program. This is our robot movement track. Our biggest challenge was image recognition. Although the API was provided, we didn't know how to use it well. So we just made the robot go straight and from start to go without taking any pictures. So we are a rookie, but in this competition, we learned their teamwork and improved our coding skills. The main participate in this of this aspect. It was a great experience for all of us. Thank you for everyone listening. Thank you.
谢谢第4组的报告。接下来我们看一下该组程式在模拟器上面的表现。有请第5组 Three School 上台报告，然后第6组 Beetlejuice 请到前面第2排准备区做准备。
Honorable judges, it's our great pleasure to have you today. And here's our presentation. So here's our team member and our assignment. So there are two main processes our program. The first is the route. So the entropy will start checking its first current position, and it will move to the object area, and it will use the AR tag to correct its angle before scanning. This step will repeat 3 times in each of the 5 areas to make the result more accurate. Then it takes a photo and saves the position. It compares the picture with the sample given by the astronauts. Once the match is found, the robot goes to the spot and reports the location. Next is the image recognition. The robot begins by taking a photo of the object. It then uses the AR tag to measure the size and match the correct cell. After that, it compares the photo with the sample and uses YOLO to recognize the object. Finally, it saves the result and moves on to the next step. So we come into lots of obstacles. In the beginning, we are not know how to write Java, so we follow tutor step by step. However, the robot didn't move at all, and it's very frustrating for the beginners like us. And we keep trying, looking for answers, reading code examples, fixing bugs, and slowly we understood how the program works. At first, we didn't understand how to control astrobeam's rotation and camera angle, so it was hard to take pictures from the correct place and direction. Many times the photos were either taken at the wrong angle or too far away from the target, so we got no points. To fix this, we use the lower left corner of arrow code markers as the center of the camera view. This helps us find the correct spot and angle to take each photo. With the correction, we follow the rules and took a clear picture of the target. Then is our image recognition challenge. We first use tempo matching, but it often makes errors when the angle and direction change. Next, we tried ORB for better results, but we still have trouble with rotation and shape changes. Then we trained our own YOLO model, but it doesn't work in the system. Finally, we fine-tuned the organizer's YOLO model, and it worked well. This post-tuning method gave us higher accuracy and better stability. So we trained YOLO version 8 on the laptop with a GPU. The batch size was 64 and we used 16 workers. The black number you see are the label YOLO used to learn from the training data. And we noticed that the accuracy wasn't improved much after 200 images. Also, black borders sometimes cause YOLO to mistake the background as a key. So we select 500 images to build the final model. And here's a quick comparison between training with 100 and 200 images. Results got better with 200, but the change doesn't have very big after 200 images. Some objects like letter and key were still confused with each other. And as what I just said, we all learn from zero, and JavaScript is much harder than the Python we learn at school, but we still know that if we never give up, there is chance, just like Dr. Sun Jensen told us. Thank you.
谢谢第5组的报告。接下来我们看一下该组程式在模拟器上面的表现。 最后没有找到 target， 没关系，谢谢我们的第5组。好，接下来有请第6组 Beetlejuice 上台报告。我们第7组 We Are Rich， 请到前面第2排准备区做准备。
Judges, ladies and gentlemen, good morning. We are Beetlejuice, and today I want to introduce my programming. First, I want to introduce our team. I'm Ryan Lee. I'm our team leader. I come from National Nanker International Experiment High School, and our teammate is from Bayment Senior High School. Our detection is use RoboFlow to train our model, but first we use Python to combine our coin and others. Like treasure to become a picture and then rotate it and become bro to have a variety of picture to train our model. And finally, we train our model with the data with about 3,600. And it performed really good on the RoboFlow website. It can almost recognizes everything on the website that I update on it. But our scope is that when we convert the PT file to the ONS file, we face out that we only have 11 classes in our model, but after we convert that, we have 47 classes after we convert it locally. So this iterated category expansion led us to lose our time on the path and others technical improves. So we didn't did very well in others mission. But after more the resource was released and we have another ONS file, so after that we finish our missions successfully. But first time in this competition, I think I'm really bad time in control. Let us have less time to improve my programming and fix our problem by the expansion of the categories. And also, I think I have to have a programming journal because after the expansion of the categories, I face the problem again and again, and I do the same thing in the whole month. So I think this is why I need a programming journal. But after this competition, I think I will keep improving myself and challenging this competition next year. So hope I can see you guys next year. Thank you.
好，感谢第6组报告。接下来我们看一下他们程式在模拟器上面的表现。
So then this is our overview in this presentation. And all right, regarding the programming part, our system mainly consists of the three parts: Rhino, Python, and Android Java code. Rhino is responsible for planning the movement path and confirming astronomy position. And Python is used to train our objective recognition model using YOLO. And then the detection results are passed into the Java code to guide astronomy behavior. For the path training, as shown in this video, we use Rhino to simulate astronomy movement with the 3D model provided in the workshop. We determine key position where astronomy could clearly capture all the target area and pass through the oasis zone. This simulation also helps us estimate the camera distance and angle needed for reporting the target item and allow for real-time adjustment.
Okay, next, after planning the path, we move on to AR tag processing. We first use navcam to capture image, then detect it. The AR tag and identified its corner points using camera calibration and coordinate transformation. We were able to crop the desired image region. This cropped image was resized to 640 by 480 pixels. To enhance the image quality, we applied a constraint enhancement algorithm and then binarized the image to make the object detection more accurate.
And once the image was reprocessed, it was fed into our model for object recognition. We chose YOLO VAN because it is lightweight and works well across platform. It's an way used to detect both the type and the number of objects in each area. To train YOLO VAN, we create synthetic data by testing those items and the target item onto background. We then use marking and the bending box annotation to generate to reverse training dataset for the model.
After training the model, we built an object detection system in Python, export it into the ARMS format, deploy it on our Java systems. This allows the system to report the item category and quantities detailed in each area. During deployment, we also face a few challenges. For example, the compass and the points look very similar, which lead to frequent misclassifications. We realized that our original training data hadn't been finalized. After applying finalization, the model detected accuracy improved significantly. And the conclusion, the technical overview of our mission. Thank you.
谢谢第7组的报告。接下来我们看一下该组程式在模拟器上面的表现。 接下来有请第8组 TNP 上台报告，第9组 United Record 请到前面第2排准备区做准备。
Hello everyone, we are Team TMP, and we have 5 members, and 3 of us are here to give this presentation. And we are the student of the departments of computer science and information engineering. And why we join this competition is because we're passionate about space technology and mission programming. And we want to apply our knowledge to a real-world mission to expand our horizon. This is the overview of our programming concepts, and it's basically moving to one point and do image recognition for the area. And the special part is that we use one photo for area 2 and 3, so the astro bee only have to stop for one time. This is the detailed process for area 1, 4, and the treasure part. First, we take a photo and undistort it. Then we identify the AR tag and crop the picture according to the locations and orientation of AR tag. Then we enhance the picture with CLAHE and use YOLO to do image recognition and identify the landmarks and treasure items, then store the results. This is the examples of the different stages of the picture. And for area 2 and 3, we use the same photo. So in a part of identify the AR tag, we differentiate the area 2 and 3 according to the ID of AR tag. And ID 102 indicates area 2 and 103 indicates area 3. And the rest are basically the same as the other area. And this is the image examples. We encountered 2 main problems during this process. First, when taking photos in area 2 and area 3, it's possible to capture 2 targets in a single image. And if we simply extract the first detected region, we may extract the wrong one for recognition. So we use AR tag content to identify which target belongs to which area. Another problem is that using simple pattern matching resulted in very low recognition accuracy. So we switched to using the image recognition model provided in the sample code. And because areas 2 and 3 can appear in the same photo, so we moved the position between area 2 and 3 to capture both targets in one image, and use AR tag content to determine which is from area 2 and which is from area 3. And individually crop the regions for recognition. This helps us simplify the process while keeping the recognition accurate. And this is our presentation. Thank you for listening.
谢谢第8组的报告。接下来我们来看一下该组程式在模拟器上面的表现。 接下来有请第9组 United Record 上台报告。第10组 Extreme 请到前面第2排准备区做准备。
Good morning, everyone. We are United Record. These are our contents we will introduce. First, team introduction. Second, programming concept. Finally, we will talk about our key technologies and challenges. Team introduction. This is a team of 5 students from different universities and fields, whose electrical engineering, information management, computer science, and urban design and sustainable development. By integrating expertise in AI, system design, and coordination, we aim to excel in the preliminary round. Programming concept. Our programming concept philosophy is built on modularity, robustness, and efficiency to meet the challenges demands. We will structure our code base into distinct modules as outlined in our project. First, dedicated modules for navigation, image recognition, and API integration, allowing parallel development. Second, reusable functions for error handling and image processing, ensuring code maintainability. Finally, we also leverage the Kibo RPC API and the Android Studio templates from the repository to streamline development. Key technologies and challenges. We use YOLO V8 nano model to identify treasures and landmarks in the area, and export the YOLO model to honest formats and use Android form honest runtime perform real-time inference on the X-Tropy machine. The second part is image enhance for model robustness. First, randomly splice 4 different pictures into a new picture to improve the model's generalization ability for multiple objects and landmarks. Second, automatically select the optimal binarization threshold according to image brightness distribution to enhance the landmark features. The above is our presentation. Thank you all for your listening.
谢谢我们第9组的报告。接下来我们来看一下该组程式在模拟器上面的表现。由于我们第10组 Extreme 不在现场，接下来我们有请第11组 TLE Team 上台报告。然后麻烦第12组 YCSH Eagle 请到前面第2排准备区做准备。
Hello everyone, we are TLE team. In introduction, we are a team built on trust and unstoppable positive. No matter what comes our way, we face it together, side by side, heart to heart. Challenges may come, but we don't back down. Because when we stand as one, there's nothing we can overcome. Theory doesn't mean time limits instead. It stands for time legendary effort. A fearless collective that turns every challenge into an opportunity to race, push beyond barriers, and leave behind legacy built not by speed, but by relentless dedication and unshakable spirit.
This program was designed to help astronauts operate machines more effectively during their missions. We use object detection technology to detect landmarks, and astrobees will patrol several candidate sites abroad people where treasures are hidden.
The most challenging part was image recognition, as the machine could make incorrect judgments due to variations in distance, angle, and orientation. To address this, we developed a program to generate more test data and expand the machine's database, which helps improve the accuracy of its recognition. Thank you.
谢谢我们第11组报告。接下来我们看一下该组程式在模拟器上面的表现。有请第12组 YCSH Eagle 上台报告。麻烦下一组第13组 OFUF 魔法小队到前面第2排准备区做准备。
Hi everyone, we are Team K20 YCSH Eagle. This is our outline, include team introduction, programming concept, key challenges, and how we solve them. Our reflection, message to astronauts, and message to future team. This is our team number. I am Hong Chen from Yongqing Senior High School. I am in charge of presentation. Yang Xiaofeng, who come from Kaohsiung Senior High School, is in charge of programming.
I'm we are from Yongqing Senior High School. I am Hui Yu, learning the principle of image recognition and model training. We prepare our presentation.
This is our programming concept. Our programming concept includes 3 steps. First, calculate the coordinate of 4 checkpoints: left, control, keyboard, and key challenges and how we solve them. In our project, we use the dashboard. At the beginning, we face several technical challenges. At first, we don't have Earth training data, so the model didn't recognize things very well. Second, our programming skill were limited, and we had to travel writing some parts of the code. To overcome these problems, we took the following steps. We tried to collect more data for training and organize it carefully. Also, we used AI tools to help us write the program. These tools made it easier for us to finish the code. In the end, we solved the technical problems and successfully completed our project.
It was our first time joining a space-related programming competition, and we didn't know if we could do it. At the beginning, it was really hard and sometimes challenging, but we didn't give up. Step by step, we learned how to solve problems and get better. During this project, we also learned how to manage our time and communicate with each other. Since we had different skill levels, we had to help and support one another. This taught us the importance of teamwork and not giving up easily. When we saw our code actually running in a space simulation, we feel really proud. This experience made us even more interested in space science and knowledge. Now we want to keep learning more and go even further. Message to Australians. We understand that the program we have written is far from perfect, but if it can contribute even a small part to your space missions, this will be a great honor for us. This experience further inspired our passion to continue exploring this changing of and fascinating field of science and technology. Go discovering what and open illustrating and discouraging. It is still incredible exciting when you successfully run a simulator for the first time. Instead of worrying about doing wrong and hesitating to begin, take a first brave step and start writing. Maybe one day it will take your ideas to places you never.
Thank you for your listening.
好，我们谢谢第12组的报告。接下来我们来看一下该组程式在模拟器上面的表现。为上台报告，请第14组 Stellar Launch， 请到前面第2排准备区做准备。
喂。Hi everyone, we are OFUF Metric Team from National Winding University of Science and Technology. I am Chen Yong. This is my teammates, Shen Hao, Qi Yuan, Qi Xuan, and Jian Yi. We are very interested in space technology and hope to use what we have learned in this exciting area. Today, we will talk about 4 parts: programming concept, critical technical issues and solutions, computation reflections, message to astronauts, and future contestants.
Next, we will dive into our programming concept.
First stage, move and take picture. Navigate from the start part to area 1. Verify position, rotate to the set angle and capture an image. Next is the image processing. Processing stage. Use AR tag to locate corner, apply histogram equalization, then run YOLO detection. Finally, we sequentially apply to the move and image processing procedures to each designated area. After processing all areas, the Ultra B will travel to the astronaut's location to receive a reference image of the target object. Then identify the treasure zone based on that image. We test a variety of path planning and image recognition strategy and ultimately choose the route through the OSIS, following an optimized path to finish as quickly as possible. We prioritize speed and stability over reward point, especially given a complexity of the image recognition algorithm.
Okay, I will introduce issue and solution. First is plan selection strategy. We found that the mission completion time has a major impact on the final score. Therefore, we decide not to let the robot stop on the easiest area on the post and instead focus on minimizing the overall mission time. After repeat trials and testing, we select a plan that passes through the most easy areas while still keeping the total mission time as short as possible, achieving a good balance between score and efficiency. The second is item recognition strategy. In the beginning, we use OpenCV's matrix templates function for recognizing landmarks and treasures. However, this method only works well for simple patterns and fails easily when the items are rotated, scroll, or overlap. To overcome this limitation, we switch to a machine learning-based YOLO model for object detection. This greatly improves recognition, accuracy, and stability, allowing our system to perform more reliable in diverse visual conditions.
Next is our computation reflection. So during this completion, we learn a lot of space knowledge and image process knowledge and some coding skills like OpenCV and YOLO V8. And we learning from mistakes. We try a lot of methods to coding, and we think it's worth and we will join again. Next is message to astronauts. We are really proud of you guys, and thank you all for your work in International Space Station. And the next is message to future contestants. Try hard, work hard, and you will get what you get. Thank you all for listening.
谢谢我们第13组的报告。接下来我们来看一下该组程式在模拟器上面的表现。 接下来有请第14组 Seller Launch 上台报告，请第15组 Europa 请到前面第2排准备区做准备。
Good morning, everyone. We are Stellar Lunch. Today, we will share our journey in creating a robust and intelligent solution for the Kibo RPC. Let's begin. First, we have this student. Our program is built around this core operation loop, a simple state machine designed for efficiency and reliability. For accurate recognition, model selection was critical. We measured YOLO V8N and YOLO V5S based on key metrics like MAP, recall, and precision. This graph clearly shows that YOLO V8N consistently outperformed YOLO V5S across all metrics. This superior accuracy made it the definitive choice for our project, guaranteeing reliable object detection. The performance of YOLO V8N was outstanding. The PR curve shows near perfect scores for all target places, with many reaching 0.995. This means our model is highly accurate and rarely miss a target. The confusion matrix confirms this robustness. This strong diagonal indicates very few misclassifications, giving us high confidence in our system's ability to distinguish different items under mission condition. Strategy was just as important as technology. Under very hard mode, we discovered a critical time bonus mechanic. This graph shows a strong linear relationship between time and score with an R² value of nearly 1. It's clear every second counts. This focus on speed led us to optimize our navigation, especially through the Oasis zones. These zones offer the points, but at a cost of time. After testing several pacing strategies, from visiting all zones to skipping them, our data showed a clear winner. Our final choice was to move to Oasis Zone 2 and then sleep. This strategy provided the best balance of points gain and the time saved. This diagram shows our final optimized path.
And next is let's learn. We learn a lot of things from this challenge, but the most important thing is the always be suitable is better than the perfect. It's because a solution is always can work is more valuable than a perfect but easy to break. So reliability is the key. And the second is the keep detailed logs. The logs help us invaluable for debugging and reporting and repeating success. So a good note is important to us. And the third is communication is a key. Regular signs and clear rules and help with each other are the core of our teamwork. So it's important to us. Okay, thank you.
谢谢我们第14组的报告。接下来我们来看一下该组程式在模拟器上面的表现。 Stellar Launch Launch。接下来，我们有请上午场最后一组 Europa 进行上调报告。
Okay. So hello, we're Team Eureka, and this is our presentation. Next page. So this is our outline. So let's introduce our team. So our team name is Eureka. So it's organized by alumni and students from FRC 6988 called the Uniparts. So why do we call ourselves Eureka? It is a planet which is covered by water. It's a planet where real space pirate story can happen, just like this year's Kibo RPC theme. Next. So this is our team composition. You can see we've been in this competition for a long time. Next. So this is our big, beautiful team branding on the right side, designed by one of our members. So let's talk about the technical aspect of our project. So in terms of object detection for board scanning, we have a main thread, which is the core programming process, where we have scanning routine traverse, which basically finds the X and Y coordinates for the URU codes and the images. Secondly, we have a scale invariant feature transform estimation, which will be mentioned later. And lastly, we have an endgame process, which basically finds the target and then goes towards the area with the target item. So under that main thread, we have a secondary process, which basically does the image processing. First, it does receiving images from the navigation and the back camera, and then crops the images for us to later train. It also runs NCNN model and also logs back the results for us to know what is happening. So you might wonder, why do we adopt this sub-thread strategy then? There's two reasons. Number one, it avoids thread blocking situations caused by high load model processing, which might cause reduce of efficiency. Secondly, it prevents potential misdetecting. When we're taking pictures, we take more than one pictures for the same area. Next. So the model we use, contrary to everyone, is YOLO V11 with NCNN framework from Nehoi's repository. Give you an idea, on the right side picture, you can see what is happening is on the Java side, we're taking images from the camera. It goes through the Java native interface, which is a bridge between Java and C++. And C++ basically does all the AI processing. It gives us the results back. But what are the advantages of using NCNN framework then? Number one, it's better for platforms which has limited hardware like Astrobe because it's optimized. Number two, it's faster than all other known open source frameworks as we're using Nehoi's repository. Next. So this is the model converting progress. You can see we went from PyTorch to NCNN. And by doing this progress, we're training a YOLO model with dynamic input. That means that we can take any images of different sizes. So this is our development process. So we first start with YOLO V8 NCNN. It was from the Nehoi's repository, although it was really although it failed last year, but it was successful as a first solution this year. But then we changed to YOLO V11 NCNN. It was a newer model, and we tried object detection and also instance segmentation. One of the problems we encountered is how we found out that object segmentation is actually not really good for overlapping objects. Next. And then we tried DEM Onyx. It was a new object detection model introduced in the IEEE CBF CBPR journal. Although it has high accuracy, but it also has low efficiency. So we tried a fusion of these two models. So we had Area 1 and 4 for DEM, and also the target task for YOLO V11. Also, we reduced the target item detection duration, yet we still have misscanning problems. Therefore, we went back to YOLO V11, and we solved the overlapping problem we encountered in the beginning by training it with a larger data set, around like 10,000 images. So next one. So let's talk about SIF estimation for target alignment that we use. So SIF, scale invariant feature transformation. So you can see as Astrobe is going through the path and taking pictures of each of the area, right? You can see on the right side of the image that this is actually not the actual image in the actual location. This is actually a reference image in the background. So what happened is that Shift will estimate the feature points of the oracle on this reference image, on this background, and then translate it to the center of the board, right? And then project the reference coordinates to the real world location of where actually the area 2 is. So therefore, after we know what the target item is, we'll directly know which area and go to the exact coordinates of where that area is, which saves a lot of time during our endgame process. Next. So this is our results. You can see we have an average score of 284.6, standard deviation of 11.7, and also, but we sometimes misscan, and we hope to solve that problem in the future. Thank you.
好，谢谢我们的第15组。接下来我们来看一下该组程式在模拟器上面的表现。好，感谢大家的用心准备与精彩分享。我们上午场的报告暂时告一段落，接下来是午餐时间，请大家到附近享用台南美食，然后稍作休息。然后下午场的报告将于下午1点半准时开始，也请下午场第一场的报告组别 Kissing Impossible 务必于下午1点20前到前面的准备区做准备。我们下午见，谢谢。
to secure our standing in the competition. In our final submission, we adopt your alternative approach. Although it forgoes target detection, it employs a mechanism to acquire bonus points. Thank you.
好，谢谢第16组的报告。接下来我们来看一下该组程式在模拟器上面的表现。
我们这组参赛同学的模拟器表现。很可惜，没有侦测到目标。
可惜最后 target 没有找到，没关系，我们谢谢第16组。接下来有请第17组 Claire 上台报告。第18组 Unbelievable Panic Speed， 请到前面第2排准备区做准备。
Hello everyone, we are Team Player, and it's our pleasure to join this Kibo Robot Programming Challenge, and I'm the presenter Zhong Yixing. And during the presentation, I will first introduce our team and talk about the programming concept, and finally elaborate on the key technical points we use. So first is about our team. We are Team Player, and this is the information about our team. We are all from National Changhua Girls Senior High School, and our objective about this competition is programming autonomous recognition and navigation for space robotics. So first is about the programming concept. We divide it into 4 parts, and the first part is about the artificial intelligence training, and next is about the image recognition and classification, and the third part is about the planning of the path, and finally, I will talk about the AR tags we use. So first is about the artificial intelligence training, because that we need to ensure the detection result to be precise. So first, this is a model of AI we use. And next, because that we wanted to let our data to be more diverse so that we can get our detection result to be more precise. So we uploaded the multiple parameters about the data. And finally, we got a chart, and this chart can also stand for the accuracy about our detection result. And next is about the image recognition and classification. So first, we conducted the AR tag detection, and this is the coding we use. And next, we draw the AR text borders and coordinate axis. And this is the coding. We divide it into 3 parts. And the first, we estimate the spatial position and orientation of AR tag. And next, we draw the borders. And finally, we can coordinate the axis. And next, we crop the image, and this is the coding for the reference. And we get the pictures. And also, we conducted the grayscale transformation and clearly about ensure the treasure recognition by the robot and capture the treasure photo from a farther position for higher score inside the oasis area. So about the attempt process. These are our strategy to avoid placing the point too apart from each other and taking multiple photos from a single position by rotating only without moving, so we can reduce the time about the movement. So finally, this is a design about our photo taking points. And you can see that in the third and the 4th points, our robot just rotates itself to take a picture, so we can save the time about the movement. And next is about, and also about the position setting. We conducted the multiple trials because that we found there will be certain situation you can see. The center of about the robot will shift outside the oasis areas. So finally, this is a final result design about our planning of the path. And because that about the limit about the time, so we address it after the competition. So this is final path, you can see that our robot will first go straight and translate itself and finally rotate. Okay, so next is about the AR text we use. We use it to guide the keyboard back to the treasure location. And this is the coding we use, and this is the movement. You can see the keyboard robot will come back to the treasure location. And the final part is about the key technical points. So first, because that we found that it will be certain situation that the detection result was empty. So we use the coding to select the highest confidence score as a fallback. And next, we also use the key coalesces marker observation because there will be sometimes that's our picture. There will be multiple landmarks our picture. So we need to select one and retain the closest one. So about the consistency is very important during the whole process because that consistency also stands for the accuracy about the result. So we keep the consistency of the image process and also the logic across function and finally the data formats. And in the end, we want to share this code with the astronaut and also stand for our reflection about this competition. From the heart of the world, launch the spear of truth. Thank you for attention.
好，我们谢谢第17组的报告。接下来我们来看一下该组程式在模拟器上面的表现。有 P 辨识成功，一个 treasure box 也辨识成功，第3个辨识成功，最后一个 compass 也辨识成功，可惜辨识失败了。接着我们有请第18组 Unbelievable Panic Speed 上台报告，有请下一组第19组 Do Box 到前面第2排准备区做准备。
Hello everyone, we are Team Unbelievable Panic Speed, and we are made of members from different schools. I'm Mario Chow, the program coder. He is Jordan, the SS coder, and Joseph Lim, who is not here, is our path planner.
First, we'll talk about the overall structure of our program. For the 4 lost item areas, we'll capture 3 photos for the first, the second, together with the third and the fourth area. Then for each of them, we'll identify and count the number of landmarks and trigger items and call the set area info function. Next, we'll move to the front of the astronaut and call the refer rounding completion function. Staying at the same position, we'll wait for the target image to appear and capture the target image, and then call the notify recognition item function. Lastly, using the image that we captured, we'll find out the type of target item and landmark that we need and move to their whereabouts and call the take target item snapshot function. Now onto our path planning process. because we wanted to minimize runtime and have a more user-friendly experience. We opted for Roblox Studio as our 3D engine. To build the simulator, we have to interpolate between different vector-free and quaternion to simulate the robot's path.
Yeah, and by having interpolation, we can simulate how astral B moves between each of the two positions. So we can know whether the astral B will stay within the oasis zone or not. And that's how we do a path planning for our program. Now we'll move on to how we take the target item snapshot. So during the first step, we'll go to each of the area, and while looking at the photo of each lost item area, we'll determine where the paper center for each lost item is located at. And if it's located close to the left, middle, or right, we'll offset our final target snapshot towards the left or right. And this goes the same for the top or bottom. So for example, we have the first lost item area image here. The paper center location is located near the left side of the screen. So for the target item snapshot, we'll offset our camera towards the left, such that the paper center is now more towards the center of the photo. And after that, I'll talk about how we identify landmarks and treasures. So to do the identification, we first had to do image pre-processing, which we achieved by first cropping out the paper using post estimation and also project points. And then we'll resize and enhance the image using clay contrast enhancement. And the second step, after we have gotten the resize and enhanced image, is to use a neural network model to identify the objects on the image. We have tried using OpenCV's template matching and also feature matching using OR before. But since these are not working very well on scale and different rotated objects on the paper, we later decided that maybe a neural network model fits better for this kind of task. Yeah, so from this image, the YOLO model will return one key and one diamond. And from this competition,
it's very fun. I learned how to create a programming project, and I learned that image detection without neural network is very hard. Yeah.
Thank you for listening.
好，我们谢谢第18组的报告。接下来我们来看一下该组程式在模拟器上面的表现。
journey and what we learned from joining Kibo RBC. That's what we talk about today. Our team, our programming ideas, the main technical challenges, and what we took away from these events. Finally, we also prepared a message for the astronauts and the future participants. Okay, here we go. Our team name is DoButs. We are 4 third-year students from the departments of computer science and information management at the Suzhou University. we are very interested in controlling robots in space. So when we saw this competition at school, we signed on right away. Our programming design concepts revolve around 3 key principles. First, stability first. We focus on reliable and consistent task execution, minimize unexpected error. Second, time efficiency. We aim to complete mission quickly by planning routes carefully to avoid unnecessary movements. Third, simplicity in code. We use a modular design for easy testing and debugging, with robust error handling to adapt to real-world conditions. In YOLO image recognition, it was really challenging to distinguish between different objects, especially since the context and the coin looks so similar. The probability of misclassification was quite high. However, we eventually succeeded in helping the model learn the features by increasing similar feature data and trying different data. We also use Java image augmentation and kept fine-tune the model. And in the end, we achieved good results. This is a view of our simulation chamber. Okay. Here are our 4 main reflection and takeaway. In general, the most important thing is that we learned the importance of teamwork and improve our problem-solving skills. Next, we use the MuseTalk technology to generate a virtual human who deliver a message to the astronauts and the future participants.
Remind us that the sky is not the limit. Our dreams can go even further. Thank you for inspiring us all and making the universe feel a little closer to home.
And welcome every challenge. Stay curious, support your team, and let your passion lead the way. You're capable of amazing things. Just sign up for Kibo or PC, won't regret it.
Thank you for listening.
好，谢谢我们的第19组。接下来我们看一下他们程式在模拟器上面的表现。第20组 Aether 上台报告，下一组第21组 Apollo 21，请到前面第2排准备区做准备。
Dear honorable judges and fellow participants, we are Team Aether, and this is our strategies in the Kibo RPC. We are students from the affiliated senior high school of National Taiwan Normal University, and we have some experience in artificial intelligence and high-power computing projects. And we implemented some AI techniques on the path finding and item recognition. First of all, we use Blender to 3D model and simulate the environment using the information given on the guidance PDFs. In this way, we can simulate the perspective of different cameras and also the paths to see if it passes the oasis zone and if it can see the different targets. Next, we want to find out how the score is calculated so that we can increase the score. we think that we found out that the path score is time score plus Oasis bonus. And by experimenting using an Oasis score of 0 and adding sleep to control time, we can find that time score is 60 minus the time of the game times 0.2. So then the hard part will be how to calculate the Oasis bonus. We can first define a few constants, such as the coordinates for the Oasis zone and the score orientation at the start and end of the path sequence. And the Oasis zone has two determined vectors, time and the distance from the nearest side of the Oasis zone. And we'll call the distance d. And below is a score orientation for different Oasis zones when the distance is 1 meter. And based on our calculations, we can derive the following relationships between time and travel distance. Then we can use a function I, which we also derived to see the velocity of the score. And using this, we can calculate I, which is the following formula. So we only need to calculate this integral, and we can define the following function, then the score I ultimately becomes this formula. And how do we find the optimal path? Well, you can use BFGS algorithm, which is like a gradient descent algorithms suited for low dimensions. We use multiple starting points to prevent only finding the local optimum, because we want to find the global optimum to maximize our score. And we can use the previously defined objective function and use Sobel sequences to decide the multiple starting points. As for object detection, we initially trained a YOLO B11 with item combination pictures with varying sizes, resolutions, and rotations, but the performance was subpar compared to the example model. So we also added different lighting and even noise to the data set, and we trained a YOLO V8 using this data set using Ultralytics, and we use ONNX on the Android Studio to code the model. And as you can see, those are our training those are the training data set pictures. As for the results, we can see that it has successfully converged to an optimum and another detection later on area 3. As for the other areas, we can just use the original path. And the final thoughts. The best orientation and path was not really used, even though we calculated a relatively optimized return path using the BFG. Well, we only tried 8,100, only used 56 cores to parallelize them.
After all, if we qualify for the international finals, we will have the chance to control the Ultra B robots above the edge. The opportunity gain such a unique experience motivate used to join the competition. At first, we knew nothing about robots programming. We watched offshore videos, read manuals, and practiced with sample code. Step by step, we understood how to control the robot thanks to Kibo grad research. Our first programming concept is to move as fast as possible while keeping the path as short as possible. To save time, we chose to take photos of target areas 2 and 3 from a long distance, even though it was a bold decision. This helped us complete the inspection quickly and maximize the chance to gain points in the loading zone. Our second programming concept is to divide the robot's movement into two different paths. One, the inspection path is for taking images and recognize object quickly. Two, the retrieval path is for actual movement to the final reporting point. However, because we decided to capture the image from far away, it caused a challenge. If two trigger areas were too close together, the robots might confuse one with the other in image recognition. Our biggest internal challenge was that we had never learned
about the Erico Maker station before. We didn't have this time to master even voices image, so we choose to load the mass test in the object resource, setting the Erico Maker that is close to the center of the camera view. However, this method still has a small risk if two areas were close together. The robots might pick the wrong marker, leading to reporting error.
In the final reporting stage, there is a strict rule that a photo angle cannot be more than 30 degrees because we didn't have enough time to learn precise positioning use local markers. We couldn't accurately control the robot angle. This made it difficult to ensure the camera was facing the target within a long angle. Today's competition, we learn so much more than just programming. We learn how to work as a team, how to research new knowledge for scripts, and how to solve unexpected technical challenges. We discovered that even without peer experience, we can push ourselves to achieve things we never thought possible. However, the biggest problem was time management. Because we didn't plan our time well, many things could not be completed perfectly. This also affected our report. We did not reach the level we wanted or expected. We realized that good time allocation is just as important as technical skills, and it's something we must improve in the future. Despite the difficulties, we are proud of what we achieved. We believe this experience will help us become better programmers, better teammates, and better problem solvers. We hope that one day our work on Earth can help us safely perform complex or dangerous tasks in space.
好，谢谢我们的第21组。接下来我们来看一下该组程式在模拟器上面的表现。第21组，接下来有请第22组 X Files 上台报告。有请下一组第23组 Jensen John， 请到前面第2排准备区做准备。
Hi everyone, we are the X-File from Taoyuan, a team of graduates from Wuling Senior High. Okay, this is our team members. Yeah, I'm Joshua, this is Frank, and this is Scott. After going through the application process of colleges, finishing a bunch of so-called learning portfolio files, in Chinese is 学习历程. We decided to name ourselves X-Files, the file that will never be uploaded to college admissions committee. Adhering the essence of learning portfolio, we take part in this competition to learn as much as we could. In the very beginning, we naively thought that routing is the most important due to existence of the Oasis rule. So we kind of spent too much time in computing the optimal path. Later, we realized that recognizing the Denmark target is way more valuable, obviously. Therefore, the core concept of our program is to perform graph recognition as precisely as possible, and then integrate it with the optimal route we calculated previously.
For us, there were two main challenges during the developing process. First, coordinate system of the keyboard environment is not intuitive. The mechanism of quaternion is also confusing to us, thanks to the math within our class. Mr. Liu, who is going to study Department of Math in NTU, he interprets the rotating mechanism in an explicit way, making it easier for us to do the calculation.
Also, we made a Python program to calculate the quaternion in our file, and that make our program work more efficiently.
Second, also the most difficult part, graph recognition. None of us have learned related coding skill before. At first, we tried a naive approach. We cut the picture into small pieces and comparing them with the templates by calculating the similarity. However, this method is both time-consuming and inaccurate. As a result, we decided to adopt AI model. And that's when the hell began. Preparing datasets, coding, running the model. None of these steps were easy. After reading some books, articles to grasp the concept of machine learning, model training, and after going through countless failed attempts, we end up training a simple model that can recognize the lemma pretty well. It felt like we were solving an equation for x without any algebra skills, and nothing worked the first time. Thank you.
好，谢谢第22组。接下来我们看一下该组程式在模拟器上面的表现。接下来我们有请第23组上台报告，请第24组 Sita 到前面第2排准备区做准备。
懂梗的人可以帮忙接一下哦。
Hello everyone, we are 真的假？
Okay, before we get started, let's talk about our team first. We are from 中人 Intelligent Robot Club, and we are consist of four different people. And Liu Xuanyan and Fang Jing are responsible for the item recognition. Fu Dengyi and I are in charge of path planning works by using Arduino. And our goal is go to Japan. So, みんな、いくぞ！ Okay, and then let's move on to our main topic. This is our key technique and how we overcome it. First, beside the YOLO model TA gave us, we still do some improvement to it. This is our label strategy. At least high level image from the database, as you can see, because if you want to label the image automatically, you will see that label in the high level image, you can always see the overlap, but this is not really good for our item recognition, so it's not that good. They will reduce the generalization ability. So the way we can came up to solve this problem is to manually label visible part only. And next is route optimization. As you know, time is score. So we want to finish the mission as soon as possible. But if you see the standard route, SOP need to patrol every single area. But we think this such waste time. So is there any solution to make the mission time shorter? Our answer is yes. If you take a look carefully, you can see era 2 and era 3 are so close. So let's take a look of era 2 and era 3. You can see both image of era 2 and era 3 can contains two era image, but era 2 image are partially be cut. So we will try to based on era 3 to do some improvement. Yeah. So we want to divide it to two different parts, so we can label it individually. So we can change the standard route to this, to drag era 3 position to era 2 position. So we can save one move to save 20 seconds. So this is very good for our type bonus. And lastly, we want to do some adjustment for our return. For local, we change area 1 coordination because originally okay, we put this to the corner. Yeah. For short distance, we change this to 8.85.
好，谢谢我们第23组的报告。接下来我们来看一下该组程式在模拟器上面的影片。 谢谢第23组。好，接下来我们有请第24组 Cita 上台报告。有请下一组第25组 Ctrl CC Ctrl V， 请到前面第2排准备区做准备。
Good afternoon, everyone. Thank you for being here. I'm Lisa from Team CETA, Group 24. Today, I'll be presenting on behalf of my team. We've previously taken part in national level AI competitions, including self-driving car contests, hackathon. All have earned some great results. Let me show you our main strategy. After running several tests, we realized that staying in the oasis didn't actually help us earn many points. So our core scoring strategy focusing on improving recognition accuracy, finishing tests quickly to get more time-based bonus points, and making sure we secure the 300 basic points. We divide into 3 stages to achieve the goal. The first stage is quick photography. We aim to rapidly move to ideal photo spots and capture all required areas as quickly as possible. Once we finish capturing the images, we move into the second stage, called unified recognition and reporting. Here, we process the photos and then identify and report the targets by running our detection model. Finally, in the third stage, we convert the treasure item with the astronaut. Once we know what the treasure is, if no matching location can be found, our fallback function assumes the treasure might be hiding in a spot where nothing was decayed earlier. That way, we increase our chance of selecting the correct location, even in uncertain situations. Before running the detection model, we clean up the images in 2 ways. We face lens distortion using OpenCV and crop up the unnecessary parts to focus on what really matters. For the model training, we use YOLO version 11 small. We manually label nearly 600 images and apply image augmentation techniques like blurring, horizontal flipping, and vertical flipping, which expanding our dataset to 7,649 images. In our best result, we reached MMP 15 of 0.87. Precision is over 0.95, and F1 score is 0.81. This part shows our key technical points and solution. We added risk control to help the system make smarter calls when things are unclear, plus a 3 retry setup for better error handling. Thanks to that, we complete the mission every time. In our best simulation, we scored 335.9 points and complete the task in just 2 minutes and 3 seconds. As we mentioned earlier, most of our score came from the time remaining bonus rather than the OSS bonus, which aligns perfectly with our time efficiency strategies. Looking ahead, we noticed that the training data for different categories wasn't very balanced. So in the future, we plan to generate our own training image to improve the recognition performance even further. We're also interested in using AR tests. By taking AR tests and calculating positional offsets, we can correct the robust direction and help it get to the best photo spots more quickly. If we had more time, we would also like to run more experiments to compare different test planning methods and figure out which one helps Astropy complete its mission more quickly and efficiently. Above all is our presentation. Thanks for your attention.
好，我们谢谢第24组的报告。接下来我们来看一下该组程式在模拟器上面的表现。 接下来我们有请第25组 Control C Control V 上台报告，请下一组第26组 Meteor Booster 请到前面第2排准备区做准备。我们将在第26组报告结束后休息5分钟。
Hello everyone, we are Team K25, Control C, Control V. This is our team. I'm Gary, he's Juju, he is Cyril, and Mochi is there. Now even didn't attend. Why do we call Control C, Control V? This is a meme that describes sometimes we pressing Control press C once didn't work, so we press Control press D repeatedly to make sure the content is copied. Why do we join KRPC? We join this robotic programming challenge not just because our teacher encourages us, but also we want to improve ourselves. We want to improve ourselves and challenge our limits to go through every step of the process.
So here's a quick overview of our process. First, the robot moves to the assigned location. Second, it analyzes the image and stores the information. Third, it moves to the astronaut location and performs another image analysis. And finally, it compares the data, return to the target spot, and complete the task. So in this competition, we mainly adopt YOLO V12 as our image detection core to address issues such as distortion and small size of auricle tag in the image. We adopt a pyramid algorithm to enhance OpenCV's detection accuracy and detailed resolution for auricle markers. For the pathfinding part, we adjust the robot's posture using a combination of various calculations, the official API, and the camera distortion metrics. Rather than focus on earning more OSIS points, we aim to complete tasks quickly to gain higher time-based score. So while working on the task, we noticed that the model struggled to detect pattern from some angles. So we add a few pre-processing technique to make sure it could work smoothly. So how do we transform the image from the left one to the right one? So first, if the capture angle was too off, we re-aim the camera. Then we remove the distortion introduced by the lens. And finally, using the size of the auricle tag, we estimated the target's position, which gave us the result that we want. So even after we actually estimated the target position using this process, we still face challenges during model execution. The model often ran into issues during operation. So we had to repeatedly tweak and adjust the model's parameters and combine them with proper preprocessing steps to achieve the best result. For dataset, we augment our training samples by synthesizing addition images from raw photos and train our model using the teacher-student method. This also took us some extra time during the adjustment process. And this saw the accuracy of each class after we adjust model, which increased many compared with past.
Throughout our journey in the KRPC, we gained much more than just technical skills. We strengthened our teamwork and communication by using tools like Discord app and GitHub, which were especially important when focusing on unexpected bugs or tech deadlines. On the technical side, we improved our Java programming skills, explored more AI-powered image recognition models. For example, we implemented YOLO V12 to include more new features than the previous YOLO V8. We also gained a deeper understanding of how Astropy, something we don't normally engage with, operates in the real-world environment. In the end, we believe that regardless of the outcome, the valuable experience we have gained
will definitely shape our growth, both academically and beyond. Thank you all for listening.
好，谢谢我们第25组的报告。接下来我们来看一下该组程式在模拟器上面的表现。然后我们有请第26组 Meteor Booster 上台报告。
Hello guys, we are Meteor Booster, and I'm Shigen, and this is Shigen. Look at these two pictures, like a critical criminal mugshot, huh? And this me and this Zhenfu. Yeah. And why do we call us a Meteor Booster? Because it sounds cool. Okay, okay. So every movie got a trilogy in 21st century. So our programming philosophy too. Our trilogy is robustness, modularity, and efficiency. And the modularity is we split the mission into 3 clear modules: navigation, vision, and mission logic. The structure makes the code easier to develop, debug, and test. The second is efficiency. Every part of our system, from image processing to AI inference, was optimized to run smoothly within the mission time limits. Oh, sorry. And the third is robustness. Space missions are unpredictable. Our code must anticipate and handle errors gracefully, ensuring that the robot can recover from unexpected situations. Since we are in space, anything is possible. Okay, so let's talk about the 2 challenges that we face. The first major challenge we face is the synchronization challenge. So at first, the robot was taking picture before it arrived at the destination. That's because our move to command was asynchronized. It started the movement, but didn't wait for the robots to finish moving. As a result, we keep processing outdated image, which caused repeat mission failures. Our fix was simple but critical. We made the movement command synchronized or blocking. That way, the robot only captured images after it confirmed arrival. This ensures the vision system always works with fresh, accurate data. But here comes the second challenge. Which is the AI vision challenge. We used to have the YOLO version 8 AI models class before we are in college. So we choose to use the Vision 8 instead of some people use Vision 11, Vision 12. But, sorry. So the YOLO Vision 8 model to detect landmarks, but at first it detected nothing, even with the right image. After debugging, we found the issue wasn't the image, but the tensor format. The AI module's output is dimensional swap like a spreadsheet with rows and column flipped. Our system couldn't read it, so we implement a tensor transposition function in Java, reshape the data into the correct format, and suddenly everything worked. The robot could see and identify objects with high accuracy. And the third one is message to astronaut. It's SYBAU. This robot here is the Laser Dim 700. He's that grid and grind guy, start from scratch, and that's a spirit I want the astronaut to know, that even you up sky high up to the universe, but still you start from the ground. And first, S stand for straight. No matter how hard the challenge is in front of you, keep going straight. If in doubt, flat out. Second is U4. U for hard. I'm not talking about the age, you need to be U for something. I'm talking about you need to be interesting about anything around you. Since you are in space, everything is basically unknown. So you must search up what is going on there, what's going on here, and be a useful heart inside you. And third is brave. Make sure to be brave, because like anything will happen in the space. Even if it's an accident, even if something that is unpredictable, but still, with a brave heart, I believe any problems can be solved. But the fourth one is aware. Be sure aware that be sure aware of any even little trouble in your spaceship, because that even a little problem, little trouble will cause the butterfly effects, and perhaps maybe your spaceship will blow up. I don't know. And the fifth is united. Just remember, the rocket science isn't just a one-man work. It's like a Kibo challenge here. It's a two-man work here. So it's a crystallization of teamwork. Trust your teammates and trust the scientists. And the afternote. Although we have previous experience with YOLO and have worked on image recognition project using team flows with anchored virus environments, but we still face many challenges during this competition. But we face the problem no matter what, right? Because life is floating just like meteor. If there were no problems and questions in life, and there will be nothing for you to look back and say, hell yeah, we did it. And for this, even after this proposal, we fail all 4 tests, I will still say, hell yeah.
好，谢谢我们第26组。接下来我们来看一下该组程式在模拟器上面的表现。那感谢各位精彩的报告，请评审老师、同学们稍作休息，我们将于5分钟后继续进行。好，那我们有请第27组 Bombardiro Crocodilo 上台报告。我们请第28组 Five Dog 到前面第2排准备去做准备哦。
Hello, everybody. We are K27 Bombardiro Crocodilo, and it is an honor to be here to present to you guys. Okay, so here go over the contents. We are going to introduce our team and talk about this design philosophy, and we're going to talk about some challenges we had in our solution. We're also going to have some reflections on the experience. Okay, so first to introduce our team, we are Bombardiro Crocodilo. We're a team of 4 high school students and 1 college student, and we are from Dan Vocational High School in Taipei. And we want to go into this competition to train our programming skills because it is very useful skill. And so our team name is Bombardiro Crocodilo because we think it is very cool because it is a crocodile and it can throw bombs. Yes, very cool. Okay, so first we're going to go over the design philosophy of our program. And so we have image recognition that is based on really traditional types of algorithms. And so it's basically like we take the original image, we have to do the distortion correction because cameras are messed up. We use fiducial markers to localize our image and also extract the target region, then pattern segmentation, geometric matching, and weighted scoring to identify the most similar template, which means according to the shapes that it identifies, it uses different power to compute the object. And we have some key technical challenges in our solution. So our biggest challenge was that a lot of times that it couldn't capture the correct information. A lot of what we captured was just noise. It didn't make any sense, and we didn't get any valuable data from the capture. So we used some. So here are some of our solutions. So we use fiducial-based marker targets, so we can do better cropping after extracting the data more precisely. And after we binarize the target location, we can look at all the things inside more effectively. And we extract the contours and we use geometric template matching, which means we have to look at the contours and compare them to a set of templates that we already have, like global similarity, aspect ratio, number of vertices, centroid distance, and feature weights. And the weights are optimized through deep learning techniques and large sample data. So here are some of the reflections of our competition experience. So this is our first time competing in the Kibo programming challenge. And we realized that it was a lot harder than we expected. In the beginning, we even considered using some AIs, artificial intelligence, to help us do the recognition, but we realized that even just using traditional algorithm-based target selection was already hard enough, so we just resorted to that. So we had to look at some of the solutions that other teams had, and we realized that there's a lot of room for us to improve. So we hope that we have another chance to compete maybe in another Kibo competition next year. And so we have a message for to the astronauts aboard the space station. So we want to say that's one small step for man, one giant leap for mankind. I know this is kind of old because it was said by another astronaut, but we want to let the astronauts aboard the space station know that just because it doesn't seem that their contribution was as much as Neil Armstrong taking his first step on the moon, that every contribution they make is also just as big as a difference as he did, and they should never look lightly on the contribution that they give to all mankind. So we have words of advice for future participants, and we want to say the same thing to all future participants, because the same way that the astronauts aboard the space station are contributing to mankind, we feel like the students should not undermine their own abilities and undermine their own contribution to humanity's greater future. Thank you, everybody.
好，谢谢第27组的报告。接下来我们来看一下该组程式在模拟器上面的影片。好，我们谢谢第27组。接下来有请第28组 Five Dog 上台报告，请第29组新手来练等，请到前面第2排准备区做准备。
Good evening, honorable judges, respected organizers, and fellow participants. We are Five Dog, a group of 5 students from National Taiwan University. We name ourselves dogs in tribute to the first species to orbit the Earth, dogs. Their bravery opened a new era of space exploration. We aim to follow their footsteps, bold, curious, and always pushing boundaries. Our program design follows a 6-step structure. First, navigate Astro B from areas 1 to 4. Second, use template matching to detect visual objects. And third, record the type and number of treasures found in each area. Fourth, move to the astronaut to report. 5, identify the target item described by the astronaut. And 6, locate the area containing the target item and fly there to take a snapshot. In practice, we address several key technical challenges. To be specific, 5 technical challenges. First, we enhance the stability of image recognition by introducing the YOLO VA model for both treasure and landmark identification. YOLO predicts bounding boxes and class labels in a single 4 frame. Compared to traditional template matching, it is faster, more accurate, and more robust to variations in backgrounds, angles, or even size. We run real-time inference on each navcam and report the highest confidence score. If detection fails, we still report the top candidates to avoid unknown. Second, we design the patrol route. Photo capture points are placed inside the OSA zone to earn bonus points, and reporting points are placed within 0.9 meters of each area's center. This ensures stable OASIS points collection and improves overall mission. Third, we notice that landmark projects in areas 2 and 3 often appear in the same frame. Since using Rhino 3D was too complex for us, we switched to GeoGebra to analyze visibility angles and identify a point that covers both areas. We also modified the Keep Closet Marker function to process multiple markers in a single frame and report them separately, significantly saving both movement and capture time. Fourth, we optimized the reporting positions for landmarks. In the original code, each area had a fixed reporting location. If a landmark appeared near the edge, the report could fail. By calculating the detected RU co-marker offset, we automatically adjusted the reporting position to better center the object and ensure successful recognition. Fifth, we improve fault tolerance phase. If the target item cannot be identified in the designated area, we analyze the previously detected landmarks across 4 OR areas and randomly select a likely region to retry. This statistically gives us at least 50% of chance of success. Kibo RPC has not only sharpened our programming skills, but also given us a deeper appreciation of the remarkable advancements in space robotics. It's been a challenging, but yet deeply rewarding journey. We have grown not only as coders, but also as teammates and thinkers. This is the end of our presentation. We sincerely hope to make to the final round. Thank you, judges, for giving us this incredible opportunity. We are 5 dogs. Thank you.
好，谢谢我们第28组的报告。接下来我们来看一下该组程式在模拟器上面的表现。 接下来欢迎第29组新手来练的上台报告，请第30组乖乖请到前面第2排准备区做准备。
Hi everyone, we are the team of students. We are the team of students from different departments who met 2 years ago while taking the course in Department of Physics in the general astronomy. That course bring us together and let us participate in round space innovation challenge at that year. Although none of us come from the space-related major, and that company journey was full of twists and turns. It also laid down the foundation for our lasting friendship. This year, most of us are going to graduate. Originally, we were each going to move on the next stage of our life, but then the Kibo RPC challenge competition appeared. So when I saw it, I feel the same playful excitement I did 2 years ago. Even though I don't know much programming experience, I still invite my old team member to take on this new challenge with me. We named our team new being level up because all us are complete beginner. We didn't have lots of experience on programming, and so we just want to have fun on the last time during the postgraduate summer. We ask AI, we ask friends, and use every method we have to get our code work. Even though none of us even have the experience to take any Java course before. As expected, we run into many difficulties along the way. From the extent we use Python syntax in Java code, and even sometimes the Android Studio refuse to syntax, and debug error is always happening in this process. That's why seeing our program finally run and being able to stand here make me genuinely happy. Here, we assume the point will be awarded when the center of astronomy enter the orthotic zone. The image below mark estimate central position. We aim to minimize the number of stepping points to reduce time spent on instrument and decentrament. Based on test results, we noticed that efficient time control yield more benefit than intentionally lingering in the orthotic area. So we decided that our strategy will be to pass by the orthotic only if it's aligned naturally with the routing. Our movement design was therefore divided into 2 main processes to marking treasure and search for the unmarked treasure. In the routed for create the treasure map. You can see that we return to astronomy position with the light shape in the negative direction. It was the intentionally to keep attribute submerged within the orthotic zone. When search for the treasure in area 1, 2, 3, we used 2 different the movement strategy depend on the x coordinate of the treasure, as shown in the diagram. To white line represent the device coordinate between the two strategies. For area 4, we simply move straight to the target. If anyone is thinking about participating in the future, I would say just trying. Don't be afraid.
好，谢谢我们第29组新手来练等。那接下来我们来看一下该组程式在模拟器上面的表现。好，接下来我们有请第30组乖乖上台报告，然后请第31组 JCLX 210219到前面第2排准备区做准备。
Okay, hello everyone. We are Team Guai Guai. Today we will walk you through our project and its highlights. First, let me introduce our team members: Zhou Boyu, Xu Shilong, Liu Guanyu, and Wu Wenjing. And first, I will to go you through the design flowchart of our project. The Astro-B will initialize some variable and start the missions. We divided the core program into 2 stages. Astro-B will move to the 4 areas first and go to the astronaut in the end. Both involve similar tasks such as taking pictures and processing them. Finally, Astro-B will go to the target and complete the mission. Here, let's move on to the 6 key points and the tasks involved our project. The first key point is area positions. In order to let the Astro-B take pictures in the following object detection, we calculate the positions of 4 areas and the astronaut. Additionally, in tackling coordinates, we use linear algebra to transform the coordinates of positions relative to the camera into world coordinates. Here is the pathfinding, which is the third part. We analyze the scoring formula and observe the remaining inside ocean zone, and finally get the conclusion that the travel time score equal to this formula. Since stopping is time consuming, so staying continuously within the ocean zone is the most efficient way to maximize the score. We simulate the travel time and the expected bonus through along the straight line segment, and apply layered Dijkstra search algorithm through all the grids in each OSIS and astronaut. And however, due to the unstable visual performance in grid 2 and 3, we later constrained down the candidate points between it to layer down the 1.5 meter camera image below. So here is the Dijkstra and our path. Okay, the next part is AR tag. We have correctly used AR tag to cut other pictures and put them into our object detection model, YOLO version. And next, which is the object detections. At first, just like the last year, we used the YOLO version 8 because it's stable, easy to use, and good documentation, right? But we later, after we experimenting many different models under the real-time constraint, we later noticed that the YOLO version 11 gave us a clear edge, which is that it not only fast during the period inference, but also give us higher accuracies. So especially when detecting small or partially accumulated object. So we decided to apply the YOLO version 11. And I think from the technical perspective, I think the most efficient, the most essential point is how we handle data preprocessing and argumentations. We didn't just collect raw image, but we use this randomly argumentation strategy. For each one image, we will use randomly apply this transformation on it, which expanded our data set 3 times its original size and make it much more robust and to the real-time variations. Okay. So after we also use Low to help us to training our data set. After repeat and repeat, we finally reach over 98% of accuracy. And you can see the IO map. Okay, last but not least, teamwork. Our team consists of many members, which is a double-edged word. On one hand, we can break down tasks into small pieces and assign them to different people, members who excel in different areas. On the other hand, we have to, the progress of one task can impact another one. So we use a lot of meeting and the GitHub to negotiate and communicating. To wrap things up, we use simulation and finally apply the Dijkstra algorithm to find the shortest path. And we use YOLO version 11 to, and with our randomly argumentation strategy, we finally reach over 98% accuracy. We also consider using hyperspectrum technology because it only needs single one data set during its training. So it's much more good, right? Today is my presentation. Thank you for listening.
好，谢谢我们第30组。接下来我们来看一下模拟的影片。接下来有请第31组 JCLX210219上台报告，请第32组 Neil Armstrong 到前面第2排准备区做准备。
Hello, we are JCLF 210-219 from the Maker Club of Xi'an Senior High School in Taichung. Today, we would like to share our experience and achievements in Kibo 2025. First, let me introduce our team members. Liu Yujin, is our instructor and he also the founder and the first president of Bongjia University Maker Club, and our captain Jin Weichen. He class fifth in NCQ programming competition, and he worked on image recognition and path planning. I am the vice captain Liu Jie, and help with PPT design, documentation, and image leveling.
Next is Xiao Chenhao. It's me. I have several road robot Olympic experience, so I focus on route paths, route design. And our main programmer, Zhao Yukai, is also focused on route design, and he has the embedded systems experience. Then we are say why we want to participate. We love space, so this competition gives us a chance to use our program skill to prove us. And so we find the teammate of WRO before and then can go to the finals at Tsukuba Space Center is also a big reason. Then
And our course philosophy is because Astropy is a resource limited robot, so we follow the best code is no code at all, and we try to simplify both our code and our path to run fast and save resource.
then is our program's key factor. We take the two part, path and model. First is the shortest path. As you can see, our paths go to the area and oasis directly. It means we need to save time. And then we combine the area 2 and area 3's recognition. It saves the extra movement. Then is oasis compensation mechanism we found. We found that the oasis bonus point is equal to the time cost. So we go to the nearest oasis zone, such as oasis 2 and oasis 3 to help us to gain more points. Like you can see, you have gained a 5.4 points. Okay. Then it's the cropping method.
First image cropping, we use Aruco to detect the photos and air test four corners, and we use web perspective to crop in. And we collect 300 photo enhancement and expand the dataset to over 2,000 images. And we split the dataset into train validation and test set in a 7:1:2 ratio. And model selection, the offshore means some objective, we use our own model. But if we just use improved accuracy, we add a 0.47 confidence threshold to object.
The last is the most important, the biggest problem we face. In the last day, when we converting our model to ONX format, we found that it missed one dimension, the object next. So to fix this, we redraw the F1 curve and lower the both confidence and IOU threshold to restore the recall. And after 4 hours debugging, we finally finished it and submitted the program at time. Thank you for listening.
好，我们谢谢这组的报告。接下来我们来看一下模拟的影片。接着，我们有请第32组 Neil Armstrong 上台报告，请第33组 Space Cats 请到前面第2排准备区做准备。
Hello everyone, we are Neil Armstrong Cyclone Jet Armstrong Cannon /N Avemuchka from Department of Computer Science and Information Engineering, National Chinan University. This is the intro of the report. And firstly, let me introduce the member. Captain, yeah, it's me. And the vice captain is Chang Hongtai. And member Yang Zhongxun, Lin Zhonghuai, 任伟成。And next is our programming concept.
In this project, our primary focus was on stability. Once we ensured that our program could consistently provide correct answers, we began working on reducing the execution time. Finally, we aim to use the save time in combination with the OSS area, OSS mechanism to earn additional points. On the right is a flowchart of our program. The following will introduce our technical points and how we overcome the challenges. At the early stage of development, we focus on completing the mission as quickly as possible, while slightly paving through the OSS area. During this phase, we experimented with using OpenCV image-based object search, but its accuracy was significantly lower than YOLO's. As a result, we eventually decided to switch back to YOLO for better detection reliability. After finishing a mission, we stayed in the OSS to try to accumulate more points. However, we found that our point gained from time saving and early completion were higher than those gained from staying in the OSS. Therefore, we ultimately abandoned the OSS strategy in favor of maximizing our total score through efficiency. This picture shows the best path we made. And this is a final path that gave us the highest score.
First, we are talking about the photo angle. The rule is angle must be under 30 degrees. So our old method sometimes fails. So we redesign the robot's position for more area. Next is our models sometimes confuse the similar icons like compass and coin. And counting the trash box and emerald sometimes error. So we use a new official model to train the model.
As we move into the next phase of our development, here are our 4 goals. First, we will retrain the YOLO model by larger dataset to improve detection accuracy. Second, we plan to use multi-thread computing to speed up image processing. Third, we will design a more time-saving and optimized route for better robot movement. Finally, we aim to run the simulator server on our own system to make the development environment more stable and visible. These 4 goals will greatly enhance the convenience, speed, and efficiency of our future software development. There is something we want to say. To astronauts in space, every line of code we write on Earth becomes a bridge between human innovation and space exploration. To our future opponents, great tech comes from always improving. Today's YOLO confusion and angle errors are tomorrow's breakthroughs. There are some experience. We learn the code step by step and finish the work. That's all from us. Thank you for your listening.
好，我们谢谢第32组的报告。接下来我们来看一下他们在模拟器上面的表现。 好，接下来我们有请第33组 Space Cats 上台报告。有请下一组34组 iTron 到前面第2排准备区做准备。
Good afternoon, everyone. My name is Ren. It's happy to be here today to introduce our designs and innovations on this competition. In the beginning, I will briefly outline the key points of our presentation today. We will introduce our team members, how we optimize on image processing and the model inferencing. We also designed a separate program to do automatic testing on our robot code and analyze the data on the Google Sheet. And we will introduce the automatic annotated system. First, I would like to introduce our team members. We are from National Tsinghua University and the National Central University. We have myself, Ren, focusing in software engineering, and Debbie focusing in model training. Brian, who focus on automatic annotation of dataset, and Bora, responsible for dataset post-processing. In terms of imaging process, to increase speed and reduce errors, we use the strategy of optimizing rotation and cropping. We use the Oracle tag position to precisely calculate the cropping area, ensuring that master critical information is captured every time. This greatly improves the efficiency and accuracy of our image process. At the same time, we also handle special cases. For example, we filter out incorrect stage Oracle text to ensure that the data for model inference is clean and accurate. Regarding model inferencing, our goal is to get the best results from the input image. We use images as input and utilize the ARGMS function to get the type of recognized object. This allows for faster and precise object recognition. To further boost efficiency, we introduced an automatic process which enhances our crawler program. We created a fully automated testing pipeline that programmatically uploads APK files to the simulate. This seamless process greatly improves our testing efficiency and reduces the need for running simulation by ourselves. For data analysis, we use Google Sheet for storing results generated by Lester Steve. Through these tools, we can easily organize and analyze large amounts of simulated results, identify key trends and patterns, and provide data-driven support for our optimization strategies. Finally, I would like to introduce our automatic annotation system. This system can greatly increase our dataset size. By automatically annotated images, we can provide richer and more diverse data for model training, further improving the model's accuracy and the generalization capabilities. And I will give it to Debbie for remaining presentations.
Okay, this time we use YOLO 11 for training. Its new West model is faster and more accurate. It's use SPPF and C2PSA attention block. This helps it find small object better. On the right, we can see how the model uses grids to find and draw boxes around objects. At first, we trained version 1. The MAP 15 was only 88.4%. Position and recall were under 81%. However, by version 13, the MAP was up to 99.3%. Position and recall also became 99.6%. It's proved a lot. At the beginning, we label the picture by hand. We label over 1,000 pictures. We used two RTX 3019 GPUs to train. The training was done on the Colab local runtime. We use Loboflow is help us manage the datasets easily. Later, we use auto labeling is save a lot of time. In the end, we label over 18,000 pictures. For each object class, we has more than 3,000 images. Like coin, fossil, and sure. This helps the model learn each class well. Lastly, we want to send some performance. Most we send Tessa, everyone, and our grad team. Thank you.
感谢第33组的报告。接下来我们来看一下该组程式在模拟器上面的表现。好，接下来我们有请第34组 i 创上台报告，请下一组35组 To BC Coding for a Name， 请到前面第2排准备区做准备。
Hello everyone, thank you for being here today. I'm Lin Yinpei from iTron Robotics team at Charlton University. Today I'm going to walk you through how we build our program for the competition, including code structure, image pipeline, the challenge we faced, and finally the result we achieved in the simulation. Our program is organized into 4 layers, and making each component easy to maintain. In that layer, we have your service, which is the default entering point of the framework, and main control, where the main test logic is executed. In the lower layer, we have item manager, which stores and manages the detected items, and vision handler, which applies YOLO models and process camera input. I will go over the pipeline details in the next slide. We also have navigator to handle navigation. In addition, we also define custom data structures like pose and item to store the information in a consistent format. Here's how our image pipeline works. The camera handler first captures the raw image and undistorted using camera collaboration parameters. And you can see these 2 images are quite similar. And the main difference is at the corner. The first one is raw image, so the line is more curved. And the second one is collaborated, so the line looks straighter. Next, the AR tag detector extracts the tag information and then crops the image. Next, the cropped image goes through preprocessing steps such as resizing and normalization to make sure the image is in the correct format to the model. Then we feed it to the YOLO model, and the model will return a list of detected items with their bounding boxes and confidence scores. Next, in post-processing steps, we filter out low confidence scores to filter out the items with low confidence scores. Finally, we apply weighted box fusion instead of non-maximum separation to better merge the overlapping items. We faced some challenges along the way. So the programming manual has no detail about class Kibo RPC service, and we end up decompile the code in Android Studio to understand it and make it work. Second, the online simulator sometimes failed without any log messages, and we could only test it line by line to find the bug, which was very frustrating. And third, training on data is super slow, and we reached to some professors and institutes for help, and eventually gained access to some fancy GPU. And we also transferred the image format from PNG to WebP to further compress the image size to increase the training process. And in our latest model, it is trained by 60,000 images and trained within 8 hours. And finally, in our early version models, it sometimes computes faster with coin. And we add multiple data generation strategies And specifically, we add some images contain single image overlapping with each other to the dataset. And here's our simulation result. And in our latest version, 1.3.5, and we achieved 286 points with 99% precision in normal form. And that's everything I want to share. Thank you for listening.
好，我们谢谢 iTron 的报告。接下来我们来看一下该组程式在模拟器上面的表现。接下来有请第35组 Two BC Coding for a Name 上台报告。有请最后一组第36组 DDDD 请到前面第2排准备区做准备。
Good afternoon, Judge and everyone. We will K33 to PD coding for a name. My name is Junho Chen, and this is my teammate, Houting He. Today, we will show how we guide attribute to find the real treasure, best the predator everyone's traps, and scale the best score. Our team come from different backgrounds, but we would rather let our code to speak for us. So let's get straight to our mission. This mission had 3 main college. Attribute must reach all target with time. Our vision system need to stay accurate despite changing light and noises. And redundancy everyone run meets we had to reduce uncertainty for stable result. To handle this, we focus on rule planning, error correction, and simulation. We run tests for different scenarios within the keep-in zone. First, real-time reporting and optical advice and help attribute react quickly if things go off track. Our solution stands on 3 pillars: smart rule planning, fixed path plus dynamic correction, keep attribute on track. Robust computer vision, OpenCV processing, and YOLO V8 boost detection speed and accuracy for error tags and landmarks. Resilient background. If reconnection fails, we cross-check feature, retry, or fail, or fall back to save point, lowering mission risk.
We use video simulation to refine our flight plans and explore the best oasis long placement. This helps us to be hover just long enough to rank up bonus points while saving precious fuel of the rest of the mission. Let's talk about the vision. We upgrade to the 4-stage pipeline: noise
reconstruction, construct boost, failure match, and multiple object tracking. YOLO 8 detection is faster and more precise. OpenCV perhaps helps us hit over 95% accuracy in test. We also adjust lighting for AirTag to ultra-B get clear shot from any angle. Test shows our mission time improved by 50%, OSS score reach more points, and vision stability grows from 80% to 95%. This shows our strategy works and can adapt to real ICS conditions. This journey wasn't easy. Frozen theme, model error, late night bugs, but it pushed us to work together, plan for failure, and keep moving. To future team, real innovation needs backup and flexibility, not just code. Thank you, Kibo RPC, for letting us group. Now let's go to find our treasure with Astrobi by our side. Thank you.
好，谢谢我们第35组的报告。接下来我们来看一下他们在模拟器上面的表现。组第36组 DDDD 上台报告。
Good afternoon, everyone. Thank you being here today, and I honored to opportunity to join this project. This is our overview, and this is a team introduction. Our team goal to design an efficient and reliable program for the Astro-B robot to complete the space mission accurately and smoothly. This is a flow chart.
Our system has three main parts: Reno, Python, and Java. First, Reno is used for path planning. We move the robot model in 3D space to plan where to take photo and how to pass through important areas. We also decide the best angle and distance for taking each picture. It's like a virtual playground to test our plan. Now for image processing. First, we take photo with SnapCam and take AR, take corners. Then we use the camera mixture to find where to crop. We crop resize to 640 by 480 and use CLAHE and presentation to improve image quality. Skin up images go into the YOLO model for detection. Next, Python handle the AI part. We train the YOLO V8N model for object detection. We chose the YOLO V8N because it's light and can run on the actual B without needing a powerful computer. We also use data augmentation to create more training images. For example, we copy the retired item image to make a larger this data set. After training, we convert the model to ONNX so it can be used in Java. This let us use the same detection results inside the Java code running on Astrobi. The Java code is where we put everything together and actually run our mission. We had a big problem. The compass and coin looks too similar. The model made mistake because the training image were in color, but the real one were rendered. Once we returned the model, we beneath the image. The accuracy improved a lot. So in short, we use Rhino for movement planning, Python to train the detection model, and Java to run it all. We train on fact item data, processed real images, and mix dict bugs. Everything now works as one small pipeline.
Kibo RFC experience. Joining the Kibo robot programming challenge was an exciting and valuable experience. We learned how to program a space robot, improve my problem-solving skills, and work closely. It was amazing to see our code run in a simulation, and knowing it could be used on the ISS made it even more meaningful. I am proud of what we accomplished and grateful for the opportunity. Thanks for your attention.
好，谢谢我们滴滴滴滴的报告。接下来我们来看一下该组程式在模拟器上面的表现。好，那感谢所有参赛者的精彩报告。口头报告呢，到此告一段落。接下来是评审老师讨论与评分的时间，请各位参赛者稍作休息，耐心等候成绩公布。我们将于5分钟后进行抽奖。谢谢。上可以享有2倍的抽奖几率。我们已经做好签在系统里了，队员跟指导老师都有哦。然后也特别感谢罗技国际公司的热情赞助。首先，我们先介绍一下奖品。我们的5奖是国家太空中心限量纪念品组，这个是限量的哦，只有我们这边才抽得到哦，所以机会难得哦。没错，这个在我心目中是最大奖啊。然后接下来4奖的呢是500元的 7-Eleven 礼品卡，有5组哦。不错，可以吃很多餐了。好，接下来我们的3奖是我们的 Panasonic 负离子吹风机。这个也是机会难得哦。对，好，然后我们2奖呢，就是我们的罗技公司赞助的罗技滑鼠，市价5490元。在这边。好，那最后我们的最终大奖就是也是罗技国际公司赞助的罗技电竞键盘，一组快要7000元哦。对，而且还是无线机械式的。好，没错。好，那我们现在来开始抽奖。我们已经把所有名单都放在上面了，给大家看一下。对，表单里面会有自己的编号哦，大家可以扫一下那个 大家可以扫一下这里的 QR code， 里面都会有它里面抽奖的名单这样子。对的，可以扫一下，这样比较好找到，就是代表我们是公平公正的抽奖，没有做签。对，好，大家扫好了吗？好，那要开始哦。来，我们先抽5奖，好不好？哎，没事了，来，哎，好，我们直接现场设定，表示真的是很公正的，好，然后我们先来抽，限量国家太空中心的纪念品，没错没错，最大奖，而且还有10个名额哦。好，很刺激哦！现在跳到哪里去了？好，恭喜我们的 Bombadillo Crocodile 欧圈宽同学，欧圈宽同学在吗？哦，好，那你可以帮忙来领。好，那我们到台前来领奖，谢谢。好，接下来我们抽出第2个限量品。好，恭喜我们的，看一下哦，24组是 JCLX 210219肖圈浩同学在吗？你吗？好，恭喜你。好，我们继续抽出第3个非卖品。我们第5组 We Are Rich 黄圈慈同学在吗？在吗？好，我们来颁个奖，恭喜恭喜！好，我们抽出第4个太空中心纪念品。好，我们的第44组有郑圈瑞同学吗？不是，Space Hero 在吗？哦，恭喜！好，接下来我们继续抽第5个，一半了。好，我们第11组大四喜廖圈品同学在吗？不在。好，那我们先请那个带领一下。好，我们会再寄给他们。好，接下来抽出第6位。紧张紧张。哦，21破壁奖谢圈云同学在吗？不在。好，那我们也先带领，然后之后再寄给他们，谢谢。好，接下来抽第7个，快没咯，很抢手的限量品。我们的第6组滴蔡圈伟同学，哦，这认识的，好，带领一下，好，谢谢。好，剩最后3组哦，要把握机会哦。第73 Unbelievable Panic Speed 林圈浩同学在吗？那有组别可以带领的吗？好，恭喜恭喜！好，最后2个哦。 哦，我们第8组，乖乖在吗？这边好，麻烦了。好，我们抽出最后一个限量纪念品哦，这世界上最后一组了。哦，第70组是我们的 Tell Me Why， 陈圈的同学不在。好，那我们先带领，再寄给他们。好，接下来我们来抽4奖5张的500元 7礼券。哦，3是谁 ？TLET 林圈家。哦，恭喜你！好，太棒了，有收获了。来，第2个。哦，30组是谁？看一下哦。DoBot 在吗？刚刚有报告的，对不对？张圈如同学，好，上台领奖，谢谢。抽出第3位。好，第6组是 Europa 在吗 ？Europa 林圈成，刚刚是不是有报告过？有同学可以带领吗？好，谢谢林圈成同学，恭喜。然后第4位500元礼券。第10是 Nebula 肖春熙同学，在吗？好，带领一下，好，谢谢。好，抽出最后一个哦，500元礼券哦。第17是 Flying Unicorn 在吗？不在。梁慧轩同学，我们再寄给他们。好，谢谢。好，接下来是最后的3个奖品了。首先，我们来签我们的3奖，吹风机。没关系。反正一个是吹凉，一个吹热的。好，63。新手来练等何圈成同学，恭喜你。好，那在抽出前2个之前呢，我们再来看一下这个奖品。好，我们的2奖还记得是什么吗？对，滑鼠，我们国际公司提供的滑鼠，你看是粉红色的吗？对，你看多么的威风啊，对不对？对 ，CS:GO， 真的国际电竞选手都在用这组。对对对，然后我们再展示一下，也是我们国际公司提供的键盘，无线机械式的键盘。哦，这打起来一定很厉害。对。再看一下，再看一下，对，再让大家看一下。好，很厉害，你看还是彩色的哦，彩色键盘，对不对？好，那好，我们来看一下我们的粉红色酷炫滑鼠，来，希望他人在现场哦，我要按了哦，好，是谁？是谁？哦，7是 Baby TRX 王圈，好，同学在吗？哇啊！哎，哇，有直播呢，哇，可惜。哇，好吧，没关系，我们先请好我们的带领一下啊，这个带领一下，再让他露个脸好了，对这个，可惜，好，我们请摄影师拍一下， 有，OK OK，真的真的。好，那抽之前再来看一下最后的键盘，最后一眼哦，它快要不见了哦。对，罗技国际公司提供的哦，真的很厉害。上次用过，真的觉得哇，跟其他键盘真的完全不一样，真的。再展示一下好了，展示走过去。对，感谢罗技国际公司提供的无线机械式电竞键盘，市价6990哦。你看你来一趟成大，又可以带走7000块的东西，哇！好，来哦，紧张吗？有谁想要吗？哦，蛮少的，好。好，那我们让他跳60次，好不好？60次，好。再剪接就好了，对不对？好，全部的人都在哦，对不对？全部人都在，好，检查一下哦，都有哦。好，准备抽咯，按咯，好，来，看一下是谁，看一下是谁。哦，76是谁？也不在吗 ？Math Random， 哇，有点尴尬哦。我们的这是有报名的，但没来现场的，好啊。还是从2奖那边开始减掉啊？没有，不行不行啊！我们还是要公平公正。主委要加码吗？有加码吗？还是还有那个限量的东西？好，有没有？好，还有哦，好。那还要抽一个限量纪念品组吗？好，好，那我现场新增哦，来，这个真的在我心目中，真的比大奖还要重要。在5组吗？好，在5组。对。老师、主任加码的好不好？来，谢谢，好，抽了，来，但可能等我们包装一下，等下结束带到柜台领取，好。哦，有吗？有吗？这是谁？72组，阿波罗21。哦，有了，终于。哎，好。等一下，好，等一下结束我们再去柜台领，好不好？领圈起，要记得哦，要记得哦。好，还有，来，主委加码的限量笔。哦，46是谁 ？NCKUMSDA 没有哇，蔡圈红好，我们再寄给他们，没关系，我们还有3次机会，3次机会，然后把握一下。 哦，有吗？57组10什么 ？Meteor Booster， 哦，你吗？好，史圈同学，好，那我们等一下都结束后到柜台领取，好不好？好，最后两个，来，最后2个哦。有吗？在哪里？哦，有吗？第11个是谁？又是 Nebula 邱圈祥同学在吗？他没来啊，你们可以代理。好，那在这个柜台领取，谢谢。好，我们现在剩最后一个哦。最后一个之前呢，我们再看一下那个。没有，你看它价值多少，对不对？有没有心动了？有。对，是。我改一下15，好不好？15组。问问爸爸。好，最后一组咯。好，我要来抽咯。第8个是谁？乖乖，又是乖乖啊！他评分80分以上啊，所以有2次哦。哦，不是同一个哦。这个刚刚也是领这个吗？哦，2个无价的哦，太棒了！好，刚刚中奖的可以直接来领了，我们准备好了，对吗？可以直接来前面领哦。那我们抽奖环节结束了，耶！恭喜大家有抽中的。那好，我们好，成绩已经出来了，那我们再稍等一下。诸位加码吗？好，看一下有什么可以加码的。我们要技术奖评吗？抽棋子，哪里有棋子？好，太棒了。那因为我们因为那个真的是非卖品，所以我们加码就只能这样子，这样才有非卖品的意义，对不对？好 ，OK， 那我们来该办正事了。来，在颁奖之前呢，我们先有请我们的国家太空中心杨善国工程师来为我们做技术讲评，欢迎。
大家好，时间过得很快，都第6届了，从第1届到第6届，然后一说我又老了6岁了哈。第1届的时候，那时候每一届大概都不太一样啊。第1届的话，那个题目比较单纯，就是只管那个第一届跟第2届就是管你跑的路径，然后还有最后它是要打一个雷射的精准图，就是2个分数。那第2届的话就是差不多啊，也是这样。到第3届以后就有改变，就是要去找东西，然后还有一个 还有一个速度，然后还有一个也是精准度，但是它就是每个的分数的weighting它没有跟你讲，啊，就是刚刚也有很多同学有去试的是看说哪一个分数，那比例重要不重要？好，那第3届那个就是我们第1次拿到冠军的那一届，那个是一个台大的学生，他们就是有在研判，他就是时间跟精准度到底的weighting是多少。那后来发觉，后来他们教他就改进了，没有差异那么大，就是时间一点都不重要，就是他的第3届那个时间就有像说我们打篮球有没有，就24秒的那个限制嘛，进攻就是24秒。但是他就你29秒进的话，无论你投2分就是2分，投3分就是3分。他的比赛那个他的分数有一点是这种方式，所以说那次我们那次第1次冠军，那时候我们主任也在现场，那时候是疫情嘛，主任还说，为什么不是印尼那个明明分数比较高，为什么反而是我们冠军？后来他印尼那个太重视速度了，结果他有一个 bonus 他不想要，他直接就冲到下一关去。然后他事实上比我们台湾队快了快1分钟多，可是问题那一届跟其他届，如果说换别的届的话，会把时间的分数会加一点的话，我们那届就输。可是台大那一队，他是那一队唯一一队有去把那个事情有去模拟说，到底是谁比较重要，所以说他就很重视把每一个关节都走完，然后最后发觉成绩不重要不是时间不重要，所以他拿了冠军。成绩很重要，成绩很重要。OK， 那我们回到我们这一届，那这一届呢，我就觉得除了队伍很多，而且我看到很好的现象，有好几队有试着去算看说，到底是大家都很好奇，去绿洲要待久一点，到底是分数跟那个时间到底是怎么样的平衡？所以很多人去做。早上就一个队伍，后来下午发觉，很多队伍都有在做这个是很特别的，就是以前前几届倒是没有这么多队伍有想到说，因为他之前没有跟你讲了，不像联考一般考试跟你讲说，这个占多少比例他没有跟你讲，好，所以说你要自己要去计算去模拟。我记得还有一个队甚至还弄出很复杂的数学的那个程式，我都看不懂的去算说它的weighting到底是什么。OK， 好，然后我们现在来看一下那个，我把那个好各组的看得清楚吗？好，开始。就是前面的技术评分大概都没有跳动，因为它是用累计的啊。如果我们是用10次的这样子跳动的话，可能会跳动的比较多。那目前它是用累计的，这样子的话，前面的变化不会大。这个蛮好。OK， 那这个是你们刚刚已经看到，就是技术最好的1、2、3嘛。那你看这边的话，你发觉sorry， 有站页。我们应该是时间关系，我们就讲一遍。它是，你看它时间的话是 反而是他第二的比较快，对不对？对不对？然后一样，那第二跟3、4时间是差很多啊，那就是很容易判得出来。但是，为什么1跟2里面是他明明时间是用的比较短，跟他分数出大，对不对？那我们看下一页，它有一个总表，它就是它每一个的那个分数出来，然后它时间的 OSS bonus 它比它多啊，所以说你是这时候就是当时就是说你要去。就是你的 strategy 就很重要，因为你如果事先知道它是哪一种的话，因为你大家找到物件啊，大家都是前面的分数都很对，因为只要都找到物件的话，一定都是满分嘛，180、60，然后最后就看你的 bonus 2个，一个是 OS， 一个 time bonus， 你要去如何做那个平衡，如何做这个平衡来拿到高分，所以1、2名大概差异大概就出在这边，然后3、4名也是这样子啊，这个是蛮有趣的，所以说这个可以给各位。下一届或什么参加就参考，就是你事实上真的要去 strategy， 觉得这蛮重要的，在很多议题的是这样，所以我们就拿这个来当例子啊。那其他应该也就是大家应该比较 focus 在想看这个前3名嘛，其他的大概我们刚才已经看到的分数，大概比例就是这样，也不时间的关系，我们就大概今天就讲到这边，谢谢。
颁奖。好，那接下来我们要公布各个奖项。首先呢是颁发，等一下，好，首先是颁发3年简报特别奖，然后此奖项呢只会看今天的简报，然后今天的精彩程度和程式的分数没有关系，然后总共有前3名。那我们先来颁发第3名。稍等一下哦。好，找到了，不紧张，不紧张。来，我们第3名，我们先请我们评审帮我们颁奖好不好？我们请曹伟老师帮我们先颁吗？还是于琦老师？那我们请国立成功大学土木学系苏于琦老师来为我们颁发3年简报特别奖第3名，得奖的是 K27 Bombardiro Crocodile， 在吗？来台上颁个奖。音乐马上出现。好，恭喜！好，谢谢，恭喜！好，那我们来颁发3年简报特别奖第2名 那我们先有请曹威老师来帮我们颁奖。好，谢谢。那第2名是K20 Aether 在吗？Aether 在吗？哦，恭喜！恭喜我们的 Aether。恭喜，太棒了！好，我们最后来颁发第1名，3年的简报特别奖的第1名。那我们邀请我们的杨工程师来为我们颁奖，欢迎。第1名有奖金多少？哦，12000，奖金12000。来，第1名是 K17 Flare， 恭喜恭喜！颁完奖之后，有奖金的请到前面那边签个领去哦，谢谢。恭喜我们的 Flare。谢谢，请到前面柜台签领据哦，谢谢。可以，那可以拿回去。好，那我们颁发完了简报奖，接下来我们颁发佳作，有10名哦，佳作有10名。那我们先请第一组 K07 We Are Rich 在吗？请上台颁奖。那我们有请一样评审，先请评审，于琦老师好。也恭喜佳作。好，恭喜我们 We Are Rich。好，那下一组佳作呢？我们还是请于琦老师来颁奖。下一组是 K08 TNP 在吗 ？TNP 在吗？恭喜！ 好，恭喜，请到前面签领据哦，那边，谢谢。好，那第3个佳作也是由我们于琦老师来为我们颁发，得奖的是 K14 Stellar Launch， 在吗？在吗？哦，开心一点，很厉害。请到前面颁奖。恭喜恭喜！好，请到前面签领据哦，谢谢。恭喜恭喜！好，那下一个佳作，我们有请我们曹伟老师来为我们颁发。那得奖的是 K18 Unbelievable Panic Speed， 在吗？耶，大家掌声鼓励！耶，恭喜你们！恭喜，到前面签领据哦，一个人到前面签，谢谢。好，那下一个也是请曹伟老师来替我们颁发。得奖的是 K19 DoObot， 在吗？大家掌声鼓励一下，恭喜恭喜！好，恭喜恭喜！好，那下一个佳作也请我们曹伟老师来替我们颁发。得奖的是 K20 Ether， 在吗？哦，又得奖了，太厉害了！恭喜恭喜！好，请去前面签领据哦，谢谢。好，那最后4个佳作，我们有请我们的杨工程师来替我们颁发，欢迎。好，那得奖的是 K25 Ctrl C C C C C Ctrl V， 恭喜！恭喜恭喜！好，请到前面签领据哦，谢谢。好， 下一个佳作得奖的是 K33 Space Cats， 在吗 ？Space Cats， 恭喜！请到舞台前面。我们看前面哦，拍照。好，恭喜恭喜，请派一个人到前面签名句哦，谢谢。好，那接下来我们颁发倒数第二个佳作，得奖的是 K35 2BC Coding for a Name， 耶，恭喜！请到台前面。恭喜恭喜！好，恭喜，请到前面签领据哦，谢谢。好，我们佳作最后一个，紧张吗？得奖的是 K36 滴滴滴滴，耶，恭喜！好，恭喜，请到前面签领据哦，谢谢，也谢谢我们的杨工程师。好，佳作颁完了，接下来我们要颁发前3名了。哦，大家紧张吗？前3名哦。那第3名呢？我们先请我们的国立成功大学张怡玲教授来为我们颁发。好，紧张吗？得奖的是 K15 Europa， 可以开心一点，开心一点。恭喜，很厉害，第3名。好，太厉害了，第3名，谢谢。那先签完领据之后，来这边等一下。对，好，接下来第2名，我们有请国家太空中心太空教育办公室郑重生总监帮我们颁奖。好，那我们要颁发第2名哦。得奖的是 K30 乖乖，在哪里？哦，恭喜！恭喜2人团队。 好，恭喜，请到前面签完领据后，在那边集合一下。好，那最后第1名，我们有请国家太空中心火箭阿贝吴忠信主任为我颁奖。好，那我们来颁发第1名哦，可以去日本哦。得奖的是 K34 i 创，恭喜恭喜！恭喜恭喜！太厉害了，谢谢。那最后呢，台南市政府为了鼓励发展科技潜力，特别颁发台南市政府特别奖，给我们前3名队伍，分别有5000块的奖金。让我们再次以热烈的掌声，邀请前3名的队伍到台上领奖。然后我们邀请台南市教育局课程发展科的张专员还有季先生来为我们颁奖，大家掌声欢迎。恭喜我们的前3名。恭喜我们前3名。笑一个，耶！好，恭喜我们前3名队伍的台南市特别奖。要派代表去前面签领据哦，谢谢。好，那快结束了，所以我们有请我们的国家太空中心火箭阿贝吴忠信主任来为我们做最后的结语，欢迎我们的火箭阿贝。
各位朋友，各位朋友、各位同学，还有可能有老师，还有我们太空中心同仁，还有台湾市政府，谢谢各位，大家午安。我想今天主要是我借这个机会回到我的故乡台南，然后昨天、今天都去吃了我最叔叔梦想的土特鱼羹， 当然可以讲我贵。OK， 多谢大家。然后我要特别感谢这一次帮我们承办的张依林老师其实我是说我特别来看他，因为我认识张依林老师，大概在美国就听过他的名字，已经认识他30年。我不，我们两个不会有差很多，所以我特地不，讲错了，再差个20岁30岁特地来成大来鼓励他，谢谢他第一个真的是谢谢他，还有我知道他的团队我听说这整个城市都是他的学生，有1-2个人就把他搞定然后还有今天我们特别，还有今天的评审的老师，还有台南市政府非常慷慨的捐赠的大概15000块，谢谢。还有张庄严的来临，还有我们知道还有台湾台湾计算力学其实我也是做计算的，以前做平行计算，这个台湾我也是大会台湾计算力学学会协办的，我已经忘了怎么写扣了。然后还有3年科技协会还有逻辑然后赠送一些奖金，还有一些他们的产品，让这一次本次活动可以顺利我想我很简单讲一下这个 Kibo 这个 RPC， 我是在2020年接的时候开始，好像那时候是第2届然后我们知道我看他的历史，大概第1届大概1000个，现在今年已经有3000个，然后今年的队伍甚至到了700多队，738队，然后参加人数是3082台湾这一次也有77队台湾在过去在这个Kibo 这个 RPC 就是在国际太空站上面的这个 Kibo 这个 cabinet 其实表现非常棒，大概在我没有记错是第3届、第4届是等于是全世界冠军去年也不错是第4届今天好像也有3代，没关系我看这个分数大家其实都差不多然后我比赛是占90分，然后 present 占了10分。我在跟我的同事开玩笑，我要是倒转回去44年前，我连站在这边我都会发抖所以各位同学都真的很棒比我那时候强太多了所以我想今年他今年的这个参赛是我想创历史新高然后我们从今天已经从台湾77队经过这样厮杀，我看前面大概10队大概分数都非常的接近我们已经选出这个代表哀创可不可以站起来一下，再让大家欢呼一下他们是阳明交大，可是跟我没关系，以前不认识他们不要，我们没有暗感绝对没有。去年是成大今年换一下交大，真的你们不简单脱颖而出我想我给你们最深的祝福，请坐，请坐。希望你们可以旗开得胜凯旋而归，加油！如果你们如果在那边真的又拿到世界冠军太空中心 TASA 太空 Space 会有赏我们会有另外的 extra 的加码然后也谢谢其他同学的热情的参与，我们明年再力，我们再见面，谢谢各位。
好，再次恭喜所有得奖的队伍，也谢谢每一组的精彩表现。今天的活动呢，到这边圆满结束，感谢评审老师的辛劳，也感谢各位同学的热情参与，祝大家一路顺心，平安回家。我们明年见，谢谢。